Uh, so basically, our college was.
Seems to be some connection problem has been happened. That is another problem of the virtual mode, sir. You
That is
get
true.
disconnected, you
Yeah.
get disconnected. Yes, sir.
Yeah.
Shailaja, can you unmute yourself and say directly to the sir, hello?
Hello. Yeah.
Hello. Hi, Kundu sir. I'm Shailaja here.
Hello. 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 Yeah. How are you?
Ekdam mast. Fantastic.
Good. Good. Good.
So
Good.
both of you
Yes.
know each other, sir? Both of you know each other? Yes, Pratiksha?
Yes, ma'am. Just a second.
Ah,
I had got disconnected by mistake.
okay.
Sir, basically, KC College was earlier affiliated to University of Mumbai, and now
Okay.
we are the cluster college of HSNC University Mumbai. And
Okay.
It's a state Maharashtra. It's a Maharashtra State Cluster University.
yeah, it's
I
a
see.
state
I see.
cluster
Okay.
university, and it was founded in 1954, and our department was came into the establishment in 1958.
I
Yeah.
So,
see.
and we are funded by DBT Stars scheme earlier, and now we are funded by DBT Star status. So, under
Okay.
this status, we conduct various programs for students as well as faculty members. Some faculty development programs also we conduct.
I see.
We had earlier conducted this national data championship, big data championship also we had conducted, and every year, at least on the occasion of National Statistics Day, we try to celebrate this day with. I mean, last year we had an international conference
Oh,
on
that's
this
great.
very day,
Okay.
and we
And
try to
previously
engage
we
our
had the
students.
sir Jamovi workshop, which is a, I
So
think
Jamovi is a
free
free
open
open source
source software.
software.
I
Last
see.
2 years we had two days program, and
Okay.
prior to
Okay.
that, yes, one day.
I see. I see. I see. I see. So, how many faculty members do you have?
Sir, including me, I 1 plus 3 plus 4.
Okay.
So yeah, so it's a
So,
eight. We eight
eight
are
one.
there in the
Okay.
department.
Okay. Okay.
Eight of us are there in the
And
department.
you have a different statistics department.
Sir, yes, yes. We have
Okay.
mathematics separate. Mathematics is
Okay.
also there, and statistics is also there.
I see. I see. I see. And what kind of programs do you offer?
Sir, we offer BA in statistics up to SY level, then
Mm-hmm.
BSc in statistics up to TY level, then
Okay.
MSc also. MSc
Oh,
unadded is started from last 2 years.
I see. I see.
And then BCom honors program is also there. And
Oh,
now
okay.
one more program, means the course designing is being done for the HNC University for data science and business
Oh,
analytics
wonderful.
by the
Wonderful. Okay.
department.
Okay. So all the courses are being taught by you people only. These eight people,
No,
eight
sir.
faculty.
No, not. Data science, I said that it's a HNC University's venture. We
I
have
see.
only played a significant role in designing that course.
I
So
see.
that
I
is
see.
being taken care by that HNC University itself. And
Okay.
the rest of the programs, yes, being which are part of statistics, they are being taken care by eight of us.
Okay. Okay. Okay.
And
Okay. So what?
even the visiting faculty, even the
I see.
visiting
I
faculty
see.
has been
I see. I
invited
see.
because
I see.
MSc is there. So we want someone from the industry and
Okay.
experienced, like
I
that
see.
is also there as a part
I
and
see. I
parcel of
see.
it.
I see. So you have these eight faculty members. I mean, all of them have the different backgrounds in statistics, or what kind of
Sir,
areas?
we all are from MSc statistics. Two
I see.
of us are a PhD. Yeah, Pratiksha just now who has spoken, she is from mathematics background.
Okay, okay,
She is
okay.
from mathematics background, and her
I see.
appointment is for the computer systems and applications.
Oh, okay,
But
wonderful.
still, she takes the with the affection. I think so.
Okay,
Prashant Chandra Mahalanobis have influenced her also, so she is taking some part of statistics too.
okay, okay, okay. Yeah, yeah, yeah. That is
And rest of us are from MSc statistics, and two of us are PhD, and
mhm.
four of us are even NetSet clear.
Okay, okay. So, what kind of area in PhD? I mean, which area you had
Sir,
done?
I have taken in the my PhD is in the you can say that population sciences,
I see, I see. Okay.
demographic. It's the
Demographic.
demographic, and
Uh-huh.
Dr. Mule, I believe that it was the data envelopment
Okay,
something,
okay.
and
I see.
fuzzy logic. And
Oh, okay.
Pratiksha, yours?
Sir, differential equations and differential geometry.
Okay, okay,
I have submitted my thesis to Mumbai University. Viva
okay,
is still
And
okay,
pending.
then I
okay.
have one more colleague, Dr. Aradhna Srivastava. She
Uh-huh.
had in the control charts. Am I
I
right?
see.
Yes, ma'am.
Yeah.
Okay, 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 okay. So, you have done from where?
Sir, from the University of Allahabad.
University of Allahabad. Oh, I see. Who was your
Sir,
guide?
the Professor Anup Chaturvedi.
Anup Chaturvedi. Okay, okay. Yeah, I know him very well. Yes,
Yes,
yes. Anup Chaturvedi. Yeah, in fact, I knew his brother also. Unfortunately, his brother has expired. Yeah,
yes, sir. Yes,
Ajit.
sir.
Yeah,
The
his
last time.
brother
Yes,
was
sir.
in.
Sir,
Yes,
Delhi
his brother
University.
was in Delhi University.
Yes, sir.
Yes, exactly. His brother. Anup
Sir,
visits our department. Yeah, yeah, yeah. Anup visits our department quite often, actually. Yeah, yeah, yeah.
yes, sir. Yes, sir.
Because he has a very good. Yes, yes. So when
The
did you when
Shalabh,
did you
sir,
do your PhD?
sir, in 2013.
Okay, okay,
Shalabh sir
okay.
was
I
also
see.
there,
I
sir.
see.
He
Oh,
was
good.
my external examiner for the PhD.
External examiner. Okay, okay,
Yes, sir.
okay, okay. Oh, good, good, good. Yeah, yeah, yeah. In fact, we had once, I think, had gone to this Allahabad University for a conference also. Anup has invited us. Yes, exactly. So we had all gone for a
Sir, in
conference. Yeah.
2001,
Okay, good. I
maybe.
think so. I forgot that. Yeah, I forgot the year. Yes, it might be.
Yes,
It
sir.
might be
Yes.
during that time. I
She
forgot.
might be there, na, sir. So how
Yes.
she can forget that she must have heard you. So that's why she has remembered well.
Yes, I think it is better not to remember those old days. Okay.
No, sir, it's always good. You always cherish your all that memory.
Yes, but may not be all the memories, isn't it? If it is not a good one, no, I'm just joking. Yes, yes, yes. Okay, okay, good, 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 good. Yeah. So, I mean, who are the audience? Can you just briefly tell me so that I
Sir, it includes the students, UG, PG students,
very good. Yeah.
as
Okay.
well as the faculty members
Okay.
from the different parts of India and Maharashtra state.
Okay. Okay. Good. Very good.
So
Wonderful.
all are interested. Whomever was interested, actually, we got the 300 responses, but I don't know, somehow 150 have turned up yesterday.
I
And
see.
right now with me, I can see 84.
84. Yeah, yeah, yeah. So, have you this subscribed this Zoom?
Yes, sir. We have
Okay.
purchased on 27th. Am I right, Pratiksha? No, 28th.
Yes, sir.
28th
Actually,
it
we
said.
have 4 Zoom accounts, but our lectures are going on those accounts. So we have purchased a special Zoom account for programs and
I see.
webinars now.
I see, I see, I see. And this is for how long you purchase these things? I mean,
Sir, this
because
is monthly subscriptions are there.
oh,
We
these are
are
monthly
purchasing
subscription.
monthly.
Okay, okay. And how much is the amount? I have no idea
Sir,
actually.
around 7,000 per month
Around 7,000 Zoom.
for
Okay, okay,
500, for the capacity of
okay,
500.
okay. For 500 people, it is around 7,000. I see, I
Yes.
see, I see. Okay, okay, okay. All right. So good, 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 good. Yeah. So what is your program actually? So this mine is
Sir,
the
actually, the awareness, I think so. That was the motto behind the National Statistics Day, is that you create the awareness among the youth, especially among
Mhm.
the youths, about the
Absolutely.
statistics. So,
Okay.
keeping that into the mind from the last 4 years, this is the fifth year, you can say. From the 5 years, we are doing one or the another program where the all the participants of this program get an opportunity to talk to the expert and
Sure.
peers of from the subject.
Sure. Okay.
And that is the way they nurture their knowledge, and maybe they will do
Absolutely.
best
Absolutely.
in the
Absolutely.
near future.
Yes. 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 Absolutely. I mean, yes. I mean, which is very
And
much
whomever
needed.
we can invite, our level best we try to invite all the experts,
Yes.
because I think so. This is the day where they can't say me no, no, we are
Definitely.
busy. They usually say
No,
yes.
no, definitely. No,
Yeah.
the thing is that let me tell you, Asaji. I mean, one
Whoever
thing.
big the person is, this day he doesn't say no to us. That is what I have observed. So I just keep into the mind that this day I'm inviting them. Rest
No,
of the day they
let
will
me
say me one or
let me let
another
me
thing.
put it let me put it Asaji also. See, say I am the dean of faculty affairs. I am no doubt that things are busy, but the thing is that if we get an invitation like this, doesn't matter in which day, we always try to accommodate. It is not that, I mean, see, these are the things which we really enjoy. Let me put it that way. It is not the administrative things we enjoy. We have to do it sometime. Okay, I mean, we have to do it. We do not have much choice. But see, these are the academic part, mixing with the students and all these things we do really enjoy. Okay, so we definitely try to take out our time. I mean, unless it is extremely impossible. I mean, otherwise we always try to take out time and try to I mean, give this kind of this kind of seminar. So I'll be always happy to do that one. And let me put it that way. Okay, and I
It's
always.
somewhere I will say that it's person to person
Of
choices
course,
different.
definitely, of course, definitely. I mean,
But
absolutely true.
let me tell you, I got almost from everyone when I have approached on National Statistics Day, they said yes to me.
Okay, okay.
So,
So,
so not to listen that no, you can say that I have marked that yes, this day I'm whomever I can approach, I will invite them.
yeah. So you have this program till tomorrow,
No, sir, the day after tomorrow.
day after tomorrow. I see.
Tomorrow, Sharma sir is going to give the workshop on meta-analysis. Day
Oh,
after
I see.
tomorrow,
Okay.
AI
Okay.
and machine learning
Oh,
workshop.
very good, wonderful, wonderful. Yes,
And today,
that is.
after your this thing, paper presentations are there for from the
Okay.
UG and PG.
I see. I see.
So
Okay.
seems to be few students might not have joined just because they might be busy in
On
preparing their presentation.
preparing their own thing. Yeah.
Yeah, because
Definitely.
that is also the another charm
No,
for them.
definitely, absolutely. I mean, that is also an exciting thing for them. I mean,
Yeah.
present their work and things like that. Sure, absolutely. Okay, yeah.
So sir, let's begin.
Yeah. Let's start. Yeah, let's start. Yeah.
Yes. Yeah, I request Dr. Aradhana Shrivastava to start with the program.
Thank you, ma'am. Good morning to all. First of all, I would like to thank each one of you for joining the second day of National Conclave on recent trends in theory and application of statistics. I bid a very warm welcome to all the renowned speakers and chairpersons who took out their valuable time and joined us today to be a part of this conclave. Dr. Debashish Kundu sir, Dr. Santosh Gite sir, Dr. Dharmendra Yadav, sir, we are honored to have you all with us today. And without taking so much time, I would like to start with the events. So we are starting today's session with a workshop which is on non-linear regression by Dr. Debashish Kundu. And it is my pleasure and honor to introduce Dr. Debashish Kundu sir to everyone who will address us now. And he is professor in Department of Mathematics and Statistics, IIT Kanpur. He obtained his PhD from Pennsylvania State University, and sir is also a fellow of Royal Statistical Society. He has published about more than 250 research papers in various reputed national and international journals, and his some of research area of main interest are non-linear regression, distribution theory, survival analysis, and statistical signal processing. His achievements have been recognized by many different awards, including Professor P.C. Mahanalovi's Distinguished Educator Award, C.L. Chandana Mathematics Award, Distinguished Statistician Award, and many more from the renowned institutions. So it is so, I can say, impossible to mention his every single accomplishment because there are a lot. in numbers. So, sir, we are blessed to have you with us today at this virtual platform. And I request you to please start your talk and give a talk to us. Thank you, sir. Over to you, sir.
Okay, thank you. Thank you, Aradhana, for the kind introduction. And I am really fortunate. I'm really happy that when I got the invitation from Asaji to give a workshop on this nonlinear regression. And it is not because only for the invitation, but because of this particular topic. Let me put it that way, because this particular topic is very, very close to my heart. And see, I am on this particular course, I am offering it for last almost like 20 years. I mean, I had developed this course in IIT Kanpur. And interesting thing is that this 20 years, it has changed a lot. Okay, along that time, it has changed a lot. And see, one of the nice part about IIT Kanpur is that in any course, all the departments can take it. Okay, so if you offer any course, all the departments can take it. And that is precisely what has happened, that when I offered this course, I mean, people from various departments, from the electrical engineering, from the computer science, from the civil engineering, physics, everybody attended. And often it happens this one that some of the faculty members also attend. Okay, and those are the really nice, challenging thing. That's what it happens. And in fact, last year when I was offering this course, there was one faculty member from the computer science department. He attended, and he did not miss even a single class. Okay, so we attended all the classes, and we used to have a nice discussions about this course. Okay, so this nonlinear regression is one of the thing which I really like it. First of all, it has all the nice components. Okay, all the components what I enjoy. First of all, it has lots of applications. I mean, it doesn't really matter in which area you look at it. It has a huge amount of applications in all the areas. Okay, that is one part. Second part is that it has a theoretical challenges also. There are different problems which are really theoretically challenging. And at the end, it has a very computational aspect also. And in fact, I like all the things. I mean, I like the computational challenges. I like the theoretical challenges. But at the end of the day, if the problem is not of any applications value, I somehow do not like it. Okay, so it has all the components. Okay, so again, I mean, whatever you like, you can concentrate on those things. If you like the computational aspect, you can do that on the computational things. I know that some of you are interested in this computation one. The theoretical aspects also people can work on it, as well as on the applications part also. There is a huge amount of applications on these things. Okay, so I'll try to share my slides. Okay, and let me just see. Can you see it?
Yes, sir.
Can you see the slide?
Yes, sir.
Okay.
Okay, very good. Yeah. So before starting the things, I mean, since Asaji has mentioned about the statistics day about Mahalanobis, and I would like to say something. Okay, because since I am from ISI, I mean, I have seen this one, that the kind of respect people do have about Professor Mahalanobis. Okay, and the reason is very simple, because the more I am getting older, I can see this one, that the kind of influence and the kind of vision he had. I'll tell you two small stories about Mahalanobis, and I think that will tell you why he's that great. First story is that, because I don't know how many of you know about him. He was not a statistician at all. He was a physicist. Okay, so he went to Cambridge, and he did his what they call the tripod, which is in physics and mathematics. So he did all these things, and he came back to India during the I think after finishing that one, and he was supposed to go back for his masters. But unfortunately, that the World War I took place. So he could not go back. And he was very, very close to Tagore. And Tagore has a tremendous influence on him. Okay. And so Tagore actually was insisting him to stay back in India and trying to do something. And there was another great person, I would say. His name was the Brajendranath Seal. He was a classmate of that Vivekananda. You might have known him. So this guy told Mahalanobis that, well, you stay back in India and do something about statistics, because that is the only thing which can change our conditions. Okay, just think about it, which has been told almost like 80 years back, 80 to 90 years back. And that's the reason that, in fact, he did not go back, he stayed back. And then after that, all these things he did. And the second thing was that he was very much about implementing computers in Indian Statistical Institute. But somehow during that time, he got a huge resistance from the employees, because all these employees used to think that if the computer comes, then their jobs will go. And so they're having lots of problems, they're having lots of these agitations and all these things. So then he got very angry, upset one day, and he told the whole audience that, suppose you are all objecting today of introducing computers in ISI, but just think about it after 50 years from today, when the computers will enter in everybody's bedroom. Can you stop it? So just think about that, the kind of vision these people had. Okay, so these people could see where we are heading. Okay, so with these two small stories, I'll start my talk. I'll be again. Since that's what I have prepared. Also, that I have not put many technical aspects. Okay, I just keep it minimum. I just want to give you the flavor about the nonlinear regression. And again, in like all the good courses, I always feel that at the end of the course, that it is not that you will get all the answers. That is simply not possible. But I think you will have more questions. Okay, so I think you will have more questions about the things, what this will happen, when this will happen, and things like that. And I hope that this particular lecture will generate the questions within yourself. Okay, so that is basically my main motto of this one. So I'm not going into the very much of the technical details in all the cases. Okay, so I just want to give you the outline, the kind of problem what you deal with the nonlinear regressions, the kind of problems what you face when you try to work out the problem. But and we'll see this one, that some of the things we have answers, but most of the things we do not have answers. Okay, so that's what that's my intention actually. Okay, so this is more or less the outline of the talk. As it is very clear that a nonlinear regression cannot be without a linear regressions. Okay, so there has to be linear regression before any nonlinear regression. Okay, and the reason is very simple, because clearly the linear regression is a part of the nonlinear regression, no doubt about that. Okay, so whatever theory, whatever computational method, whatever things we are going to develop about the nonlinear regression, it has to hold for the linear regression. There is no doubt about that. If it does not work for the linear regression, then there is something definitely wrong. Okay, it's not going to work for the nonlinear regression. So that's the reason that we need to understand the linear regression reasonably well. Okay, so we need to understand what kind of intricacies, what kind of problems, and those are the things. So that's the reason that the linear regression plays definitely an important role in this manner. Okay, so that's the reason that I'll be talking about the general model, and particularly the simple regression model, and then I'll be talking about the multiple regression model. And by the way, this multiple linear regression model becomes one of the major thing in the machine learning today. Okay, so if you look at all this machine learning technique and all these things, they're using it in a huge manner about this multiple linear regression model. So it becomes, again, people are redo the things and doing it in a much better way for the multiple linear regressions. And I will address those things, the kind of new techniques which have been evolving in the multiple linear regression, and those are important because we need to know those things because some of the things can be applied even for the nonlinear regression also. Okay, then I'll be talking about the general nonlinear regression model. Okay, but one of the major difference between the linear regression model and a nonlinear regression model is that the linear regression model is more or less as an uniform method. Okay, that means that we have a regression setup, we have a simple linear regression setup, and we have a general theory. Okay, sometimes it may not work, but again, the kind of modifications we do, which is in a general frame. But when you go for the nonlinear regression, that may not be the case, because what we'll see is one that it very much depends on the nonlinear model. So that means, so that is, I think, one of the major difference between a linear regression model and a nonlinear regression model, because it very much model dependent. Okay, so we may not have, we have some general theory. Definitely, we do have some general theory, but that general theory may not work in a very, very general manner. So we have to look at the specific cases sometimes in a different way. Okay, and so that's the reason that those specific cases are also very important. And those are important because those things have lots of applications. And one of those specific case, I'll pick it up, and that's the reason that I put this one as a special case. And this particular special case, I have picked it up because what we'll see this one, that this has a huge applications in the engineering literature, particularly in the signal processing, and that is also which is in my area also. So it also has played an enormous role in that particular area, and that's the reason that I'll be talking about that special case also in details. Okay, and then we'll be going for some of the related models. Okay, so that is more or less my outline. So let me just start with the introduction. What is a regression analysis? Okay, in general, if you're looking at the regression analysis, if you're looking at in general the statistical science in a broad, okay, this regression analysis actually is there for a long time. Okay, it is not only it is a today's phenomenon. I think this is one of the most ancient the statistical technique which has been used, and the main idea about this one is that we are trying to find a relationship. Okay, we are trying to find a relationships, what we call in the statistical literature as dependent variable, but in the modern terminology, all the computer scientists what they call this one as an output. Okay, which is a very, very standard. They do not call that dependent variable; they call the output. Okay, this is a very, very standard one, and there is a reason behind it also. When I'll come to this specific example, you'll see this one, that why it is called output, and we have more independent variables. Okay, and often they call in the statistical term they call covariates or predictor, but in the new the computer scientist term they call the features. Okay, sometimes the predictor also, but not the covariates. Covariates is a very, very typical word what the statistician use it. Okay, so it's a very, very standard one. I mean, that's the reason that what we'll be seeing it again and again. We'll be talking about the relation between a dependent variable and the independent variable. Okay, and that is being there. Okay, so that is basically the regression analysis. And what we will see this one, that these are the things which will be very, very useful. It is not only for the prediction purposes that we'll be doing it for the prediction one, and also it will be very much used. What it is called, we'll see this one, that what will be used it, what is called the compression purposes. I'll come back to this one. I'll describe those things. That is called the compression purposes. So the prediction definitely is one of the most important part for any regression analysis. And the second thing is what is called the compression. I'll come back to this one, and I think I'll give the example What do you mean by that? As I said, I think the regression analysis is one of the most ancient tool, okay, which has been used in analyzing data. Okay, so doesn't matter. I mean, you obtain the data from the different experimental study. Okay, you obtain the data from the different experimental study. It can be biological experiment, it can be physical experiment, it can be chemical experiment. It is there, and you try to analyze the data. Again, you try to find the relation. And if you're looking at the history from where this the regression analysis came into, I would say, existence, came into picture, I think it goes back almost like around 200 years back. I'll come back to that. I'll tell you when it first came, almost like 200 years back. And at the beginning, it came to analyze basically all those astronomical data. You obtain the data from the stars, and then you try to analyze those data, the brightness and all sorts of things, and you try to analyze the dependent and the independent variables, and that's what you try to use the regression analysis. Okay, before going into the regression model, let's talk about the model. Okay, so what is a model? I mean, if you're looking at a general terminology, a model, the model is nothing but an explanations of a physical phenomenon. Okay, so it's a theoretical explanations. You have a theoretical. You try to put some theory for a physical phenomenon. I think nowadays, one of the clear-cut thing is that we try to put a model of these COVID-infected patients. Okay, so you can see that there is a biological phenomena going on, okay, across the world. Every day people are getting affected. So the number of people which are getting affected, we try to put a theoretical explanation to this one. So that is one type of one. It can be lots of different other types also. I mean, how it is being spread. I mean, how the geometry of this spread. That also can be another model. I mean, which may not be only the number, maybe the density. Okay, so those kind of things, or how it is being affected an individual person. That can be also another model. Okay, so basically you try to put some kind of I would say the mathematical structure, the theoretical explanation. I mean, I put this one as a mathematical structure of some physical in the sense in a very general term. I mean, it can be biological, it can be chemical, some phenomena which is going on in practice, what you can see, what you observe, but you try to put some kind of the mathematical explanation, some kind of a mathematical explanation to this one. Okay, so first, of course, we try to express this one verbally. We try to see that how it works, how it is going to work, and then we try to make it more formal, try to put equations and things like that, and that's the way we try to make it more formal. Okay, so that's the model. But this is, I think, one of the most famous quotation I have seen regarding model. Okay, and this one came from one of the famous statistician, George Box. By the way, he is also the I think the son-in-law of our Fisher, I think that David Cox. So this George Box, he's a famous statistician. He has done lots of work on the time series and even the design of experiments also. He has made a very, very fundamental comment in 1976 in the paper in the journal of the American Statistical Association. He made the comment that all models are wrong, okay, but some are useful. Okay, I think it's a very, very important question. Okay, it's a very, very important question. Very, very important statement, and we should keep this in mind. Okay, we should keep this in mind. That I mean, that means, I mean, what does it basically mean? I mean, it basically tells you that when you make a comment, this is the correct model, this is a true model, it does not make any sense. Okay, I mean, it simply means that. Okay, so you have to be very, very careful to make a statement that, well, this is the correct model. So finding the correct model may not be the correct thing. Okay, so that's what basically this statement says. So all models are wrong. Okay, but of course, that does not mean that we try to search for a good model. Okay, but some are useful, so it should be useful. Okay, that's what it says. And so, as I said, I mean that means that it simply basically means the correct model may not mean much. Okay, since all models are wrong, the scientists cannot obtain the correct model by excessive elaborations. I think this is a very, very important part. I mean, which basically means that, well, you try to put more and more into a model. I mean, in a mathematical term or in a statistical term, whenever we are talking about the excessive elaboration, I mean, let's think of in the today's scenario, if we are looking at the number of the COVID affected patients. Okay, so now if you try to put more and more predictor, okay, that's what the terminology what you are using it. Okay, if you are using the more and more predictor, it may not give you a good model. Okay, I mean, for example, I mean, suppose you are looking at the density of a particular place, or maybe age, or maybe something more. I mean, if you keep on putting more and more variables, that may not be the correct thing to do. Okay, that's what it basically says, that we should not go for excessive elaborations. On the contrary, one should look for an economical description of the natural phenomena. I think that is a very important one. And whenever you're talking about an economical description, which simply means that, well, I mean, as far as the mathematical terminology is concerned, which simply means that, well, we should have a minimum number of parameters. Okay, we should have a minimum number of parameters in that sense, so that it is becoming an useful one. That is the most important part. So we should have a model which is, of course, has to be useful at the end of the day. I mean, otherwise it does not make any sense. I mean, it has to be useful at the end of the day. But at the same time, it should not be too complicated. If it is too complicated, it is not useful. Okay, I mean, people are not going to use it. Okay, and I think one of the prime example, I mean, I'll be giving this one, of course, the gas law. That is, of course, the simplest one. Or if you look at our Einstein's E is equal to mc square, because it's so simple. Okay, it's so simple, but it is, I think, one of the most useful one. Okay, so you can see that's a model. That's a model E is equal to mc square, and that's a relation between the energy, mass, and the speed of light. Okay, and it's such a simple relation. Okay, it's not a very, very complicated relation. Okay, it's a simple relation, and that's what it tells you, that, well, I mean, that's basically shows that I would say that the greatness, the great scientists. Okay, that's what it shows, because it's a simple one. Similar thing, actually, you can see this one, the Cramer-Rao lower bound. I mean, such a simple one. It's a model. I mean, it gives you. I mean, that's a nice relation, which is so simple, and that's the reason that it is so useful also. Okay, so that's what it says, that over parameterizations or over elaborations. That means if you put more and more parameters in a model, which is definitely not the showing of the greatness. It basically shows the mediocrity. Okay, so that's what it tells you. Okay, yeah, exactly. I think this is one of the nice example about the effectiveness of a model. I mean, let's look at our ideal famous gas law, which basically says that the PV is equal to RT. Okay, where P is the pressure, V is the volume of the gas. Okay, pressure, volume, and R, of course, which is a normalizing constant, what they call the proportionality constant. That's what it is, and T is the temperature. So at any particular temperature, the pressure and the volume, they're inversely proportional. For a fixed temperature, the pressure and the volume are inversely proportional. That's what it says. Okay, so this is that PV is equal to RT. That is the famous gas law for the ideal gas. Okay, So now let's go back and let's look at. It is not exactly true for any real gas. Okay, I mean that is the, because if you go back, if you go and try to do this one, if you try to do it experimentally, you will not be getting it this exact relation for any ideal gas. You are not going to get it. But definitely, this is a very, very useful approximation. It's a very, very useful approximation for the physical behavior of any gas. Okay, in terms of the physical, the molecule of the gas and things like that. So it's a very, very nice explanation. Okay. So for such a model, there is no need to ask whether this model really true. Okay, I mean nobody asked this one because that's what people have observed it. Okay, even if I can say this one that it may not be exactly true. Okay, I'll come back to one of the simplest one. I mean, I think at this particular point, it is worth mentioning. We can think of. I think there the statistics plays a very, very important role. I mean, this I think what we called as the deterministic model and the stochastic model. If you're looking at a deterministic model, which I think makes it very rigid, okay, and that's what this the PV is equal to RT. That's what it is. But you can make it a stochastic where some the randomness is also there, which makes the model more flexible. Okay, but anyway, I mean, I'm not going into that one. I'll be coming to this for the specific one. But as you can see that because all of you are from the statistics one, so that makes the model more flexible, more acceptable, and that's the reason that nowadays you will see in all the cases there is a the stochastic model become more important. Okay, and yeah, that's what it is. Okay, so in this case, if truth is to be the whole truth, that means whether exactly PV is equal to RT is going to happen or not for any real gas, definitely the answer will be no. Okay, the only question of interest is the model illuminating and useful? That means for any ideal gas, is this happen? Can it tell it at least something? Answer is definitely yes. That means my pressure is inversely proportional to the volume. Okay, that's what it is. Okay, so that's what I'm trying to say. That well, it has to be useful. Okay, that's what it is. Okay, let's come to the specific one about the regression model. That's what we'll be talking about. The general form of the regression model. I mean, what we can see, which is in this form. That is yi is equal to some function f of xi beta plus ei. I'll come back. I try to explain again. This yi, according to this one, which are the output variable or known as a dependent variable. This xi's, as I mentioned, what are called the independent variable or the features, and this beta is the unknown parameter. Okay, beta is the unknown parameter, and here it comes. I mean, that is the nice part about this stochastic modeling. We have some kind of an randomness in the model. That means some kind of we always try to accommodate some error. Okay, so it is not that yi is equal to f of xi beta. No, that is not the deterministic. We are not, as a statistician, we do not deal with the deterministic model. I mean, we do allow some kind of a variability in the model itself, and that is there in the ei. Okay, I put that comment last at the end that all the terms can be vector valued. I'm coming to this one, but before that, let me try to explain about this ei term. Whenever we are talking about this error term ei, this ei actually it's a very, very important and the interesting thing, because when we talk about the error, as a statistician, we are looking at as an overall error. Okay, what do you mean by the overall error? This overall error can be what you can observe in the data itself. That means in getting the YI itself, you can have an error, or you can have an error in the model itself. That also you are putting it, everything you are putting it in the error EI. Okay, everything you are putting in the error EI. So that's what this model stands for. So whenever we are talking about that YI is equal to f of xi beta plus EI, that's what it stands for. That means this EI, it comprises all the errors. Okay, all the errors of course, we have to have certain assumptions to do any further thing. That is of course there. But keep it in mind, whenever we are putting this error, it includes everything. That means it can be error in the relations between yi and the xi's. It can be relations in the function itself. All these things we are putting it into EI. But one of the most important thing here, that xi's are fixed. Okay, so there is we observe xi's. We observe xi's. There is no randomness in the xi's. Okay, there is a completely different way of looking things when we may not observe xi's, but we observe certain randomness over there also. But we are not talking about that. Okay, we are not talking about those things. We are not talking about the regression model. They call the random effect model. So we are not talking about that one here. Okay, so we will be mainly talking about when my xi's are fixed. Okay, and you observe yi and the xi's, and we have this model. Okay, so now I have put that all these things can be vector value. See, you might have seen, I mean, I'm pretty sure that you have seen that for the linear regression, that xi's are vector valued, but yi is a single point. Okay, so that means which is in R, which is a real value. But I will show the example that where you will see this one, that each yi also can be a vector value. Okay, each yi can be vector. It can be 2-dimensional, it can be 3-dimensional. Okay, so you'll see this one. I'll show the example, and which is of course not in a standard the linear regression. We can put this one as a non-linear regression, so that each of the yi's also can be a vector value. Okay, so what is our problem? Our problem is that, I mean, at the end of the day, what we'll see this one, that our problem is we observe the data. Whenever you're talking about the data, which basically means you observe the data xi, which are the independent variable. We observe the data yi, which is the dependent variable, xi and the yi. We have the relations, know the function f. What is not known? We do not know beta. Okay, so our problem is that we try to find out the beta. Okay, so that is basically our whole problem in this the regression setup, the regression model. Of course, we have to have certain assumptions on the EIs. Then only we can make some reasonable estimate about the parameter. I hope everybody can hear me. Is that okay?
Yes, sir.
Okay, I'll just make a comment here. I mean, if you want to stop me, please don't hesitate. Okay, so just stop me. I'll be very happy to stop it, and then any questions if you have in between. I mean, you don't have to wait till the end. I'll be very happy that if you stop me if you have any questions. Okay. Hope
sir, students want to be able to stop you because they can only put messages in chat box.
Okay, they can send me the message. Actually, they can send me the message because I'll be able to see the message. Okay, so if anybody wants to send the message, I'll be very happy. Please do this one. Okay, so don't wait till the end. If anybody wants to send a message, because I'll be able to see the message and I'll answer that one. Okay, so to all the students, if you want to stop, just send a message and I'll definitely try to stop it and try to wait till the end. I mean, okay, all right, yeah. So let me continue. Okay, there are 3 different regression model which are mainly popular. Okay, I mean the most important. I mean, let me put it that way. Okay, of course, one is what you people have studied. I mean, the most popular one, what is of course the linear regression. Okay, that's what it is. So when that f is a linear function of beta, okay, it is called a linear regression. It's called a nonlinear regression if f is a nonlinear function of beta. Okay, so that is an important part. I mean, this linear regressions and the nonlinear regressions, it is nothing to do about excise. It is all these things are being categorized only in terms of the parameters beta. Okay, so whenever you are talking about a linear regression, that means it is the linear in parameter beta. When you talk about the nonlinear regression, that means you are talking about the nonlinear in parameters in beta. Okay, that is an important thing. Okay, that is one of the important things you should keep it in mind. There is another huge literature when, see, so far, whenever I am talking about the linear and the nonlinear, I mean, as I had mentioned at the beginning itself, that the functional form f is known. Okay, whether it's a linear or nonlinear, the functional form f is known. But there is a huge literature which is there when that if the functional form f itself is not known. Okay, and that is called the non-parametric regression model, and that is a completely different way of looking at things. So I'm not going to talk about that, the non-parametric regression at all here. Okay, so I'll be mainly talking about the linear and the non-linear regression. Okay, I mean, that is a completely different area. Okay, those are interested, I mean, they can have a look at that. Okay, now let's go back to the very, very basic, the linear regression model. I mean, which is the most fundamental one, I think, and again, I think one of the most useful model, most ancient model, which has been studied, not only in statistics, I think in general science, I would say. And it can be represented in a very simple manner. And I think, as I mentioned at the beginning itself, that the reason it is so popular, because it is simple, okay? And it explains many things in many scenarios, okay? And which is simply can be written as yi, which is beta naught plus beta 1 xi plus ei. Well, I mean, all of us have seen this one, and we know that yi is a dependent variable, xi's are the independent variable. This beta 0, beta 1, they are unknown parameters, and these are the intercept and the slope. Those are the things, and the ei's are the error term. So our problem is that under suitable assumptions on the error term, based on the data xi, yi, I want to estimate beta 0 and beta 1. Of course, here everything is scalar. Your yi is scalar, your xi's are scalar, and your beta 0, beta 1, everything is scalar here. There is no vector here. That's a simple iteration. Okay. As I said, that I have the data y1, x1, y2, x2, yn, xn, and based on the data, I want to estimate beta 0 and beta 1. Okay, and which is the minimum assumptions on the error term or error term ei. And the idea is very simple. I have a bunch of points. Okay, I have a bunch of points on the x and the y axis, and I want to fit a straight line. That's it, nothing more than that. Okay, I want to fit a base straight line passing through that. Okay, and of course, in that case, one of the standard thing, because I have this error term ei, and when I'm trying to fit the best straight line, I want to make minimum error. That's what I want to do this one. Okay, I want to make a minimum error in fitting that straight line. As I said, this is first started actually by Legendre in 1805. That was the first we could get this one. Well, I could not read his paper. It is in French. I was going through this one, but of course I could not read much. But again, they were trying to do, again, I mean, as I said, I mean, they were trying to do it for the astronomical data. Okay, so they have the data which are being obtained in the different astronomical study. They used to have all those telescope and all these things, and they used to get those data, and they are trying to fit a simple linear regression model. Okay, way back in 1805, the first paper, the first attempt which was being done. Then it come, of course, the famous Gauss in 1805. Then Gauss has also discussed in 1821. And then, of course, I think the most modern one came up by Galton, who has discussed actually in the biological study in two consecutive papers in 77 and 85. And then, of course, Fisher put it in the proper theoretical framework in 1922. Okay. I think Galton is the first person who used the term regression. Okay, I think he's the first person who used the term, the word regression. That's what he has used, and then Fisher, of course, he has used that. So now let me tell you briefly what they have done. I mean, I think that the main contribution about the Legendre and Gauss, the Legendre was that he had introduced, I mean, about the least squares. I think which is a very, very natural one, because you have a bunch of points, you want to fit a straight line passing through those points, and you have a straight line which can have a different straight line, you can fit it. Which one gives you the best one? You're looking at the distances, the vertical distances from the point to the straight line. I mean, it can be both from the below and from above, and you're trying to minimize that distance. That's it. That's what the Legendre used to do it. Gauss actually, during that time, he introduced this normal random variable. So he make that further assumption that the errors are normally distributed. Okay, so that's the way he has developed things. But I think Fisher is the one who is the first time who has talked about the confidence intervals and all these things. I mean, he could realize that it is not only the estimate which are important, but I think unless you can give something more to it, that means what kind of errors you are making in an estimation, and an estimate does not make much sense. I think that was the first time Fisher has introduced about the confidence interval about the estimate. Okay, so this is about the brief history, and now, of course, there is a huge literature which is going on now about this, even simply about the linear regressions. Of course, mainly for the multiple linear regressions. I'll come back to this one, which are there. There are lots of these, the machine learning technique which are going on. I'll come back to that. Okay, which is a recent phenomena actually. Okay, now very simple, very common approach. What you try to do, you try to find out what you called as the least square estimator, which is yi minus beta naught minus beta 1 xi squared, and you try to minimize, because you know these xi's and the yi's, and you try to estimate beta 0 and beta. I think all of you have seen it actually nowadays, even in class 12 also. We are giving these things. Okay, we are teaching all these things. Simple linear regressions. That's what it is. Now, let's look at these questions. Okay, some of the questions which are very important. I don't know how many of you have seen this thing, but I think these are important questions, even for a simple linear regression. Now, how to obtain the estimates? I mean, I'm trying to minimize that residual sums of square, that is summation yi minus beta naught minus beta 1 xi square of that. I'm trying to minimize that residual sums of square. How to obtain the estimates? These are very simple. You just simply differentiate, put it equal to 0. Actually, what we can show that that particular function has unique minimum. Okay, and so you can get an explicit solution. We know, all of us know that what are the solutions. So how to obtain the estimates? They're very simple. Is it possible to obtain the confidence intervals of all these estimates? Yes. if we have the assumptions of normality, it is always possible to obtain the confidence interval in an exact manner. Okay, we know that because we can find out the distributions, and based on the distributions, we can find out what are the confidence intervals. Okay, but again, as you can see, that we need to put an assumptions of the asymptotic. We need to put assumptions that the errors are normally distributed. The natural question happens that, well, what is going to happen if the errors are not normally distributed? Yes, if the errors are not normally distributed, we cannot obtain the exact confidence interval. But of course, what we know that we can obtain what we call the asymptotic confidence interval. That means at least we can say what is going to happen as my sample size is large enough. Okay. Of course, nowadays we have a much more better technique. I mean, we have a bootstrap one. We can have a bootstrap confidence interval, definitely, even for a small sample also. Okay, so that problem also can be addressed. I think more important question is, are they robust? Okay, what do you mean by that? Okay, whenever we are talking about the robustness, I mean, I don't know how many of you have seen this. The robustness simply means, so it is like this. I mean, you have this bunch of data, yi and the xi's, okay? And whatever data it can be. I mean, say again, it can be the number of COVID patients. So suppose your yi is the number of COVID patients, that is your dependent variable, your xi's, maybe the total number of people in a particular place, that might be the xi's, okay? So, so now, if any one of these, suppose there is a mistake in the data, or there might be some kind of a spike in the data. So now, if there is a small change, either in the xi's or in the yi's, if the regression line differs a lot, that means just suppose I have a data point, say 50 data points, okay? And I have one nice regression line, which is yi is equal to beta naught plus beta 1 xi. But now suppose I have a just problem in one of the yi's. Okay? I mean, it might be either too large or it is too small, or maybe one of the xi's. It might be either too large or too small. And now, if just because of one data point, is that regression line is going to change significantly. If that happens, that if it changes significantly, then we call that they are not robust. That means it is very much susceptible, that it cannot handle a little bit of perturbations, okay, which is not very good for any estimates which are not very good. And what we know already, that, well, the least square estimators, they are not robust at all. That means if you change slightly one of the variable, then the estimates differ significantly, okay? And so therefore, they definitely are not robust, okay? So that means we might have to think something else. That's what it is. That's what it is. Well, one of the natural question following this line, one of the natural question is that often it is being told that, well, if, let me just see, somebody has asked some questions. Oh, I see. Somebody asked that one, that will you explain what is a robust again? Yeah, sure, definitely. Let me just explain. Okay, so the robustness basically means that, again, suppose I have the point xi and the yi's, okay? Suppose I have the point xis and the yi's. Okay. Let me be very, very specific, okay? Suppose I have this again. I'm coming back to the same example about this, the total number of COVID patients and say maybe xis, as I said, I mean, some of the dependent variables, whatever it is, okay, in a particular place. Okay, suppose I'm looking at the two places, and we know that these two places these two regression line should behave in a similar manner. But suppose there is some problem with one of the data points. Okay, so some, out of say maybe 100 points, some points I have some problem. Okay, that means that maybe some of the yi's are very large compared to the other yi's. Even if the xi's are same, maybe it is by mistake. Maybe it is by actually it might be true, but that is the data in that particular place. Okay, what we call in the statistical terminology, they are called the outlier. Outlier basically means it does not satisfy the regular pattern. Okay, with the rest of the data points, they are called the outlier. Now, if you're looking at if you have simply the outlier present, okay, if you have simply the outlier present in a data, so you are trying to fit you are trying to fit a straight line through those. The question is, if there was no outlier, whatever would have been the estimates, if we have the outlier, are those estimates differ significantly? Okay. Unfortunately, in case of the least square estimators, even if there is only one or two outliers, that means if one or two data points are either very big or very small compared to the rest, it affects the estimates very significantly. That means that the least square estimators are not robust. It is very, very susceptible to the outliers. Okay, so that's what it is, and that's the reason that the least square estimators may not be preferable all the time. Okay, particularly if we can see in the data points, there are few outliers, and that we can easily see that if we simply plot it, if there are few outliers, that may not be a very good thing. Okay, so so those are the things we have to look at. Okay, is it clear? Okay, so so that's what the robustness means. So that means they are not robust. Okay, they are not robust. The last one is that, are they consistent? What do you mean by the consistent? The consistent, that's a very, very important concept. And again, so what do we expect? So we expect that, suppose I have this bunch of data points, xi's and the yi's. Okay. Suppose it is coming from some physical process. Okay, I have these xi's and the yi's. So that means if we have more and more data points, we should have a better and better understanding of the underlying physical process. That's what we expect. So that's what means that, well, if the original physical process has some beta 0 and beta 1, and if we have a more and more data points coming from that process, so my estimates should go to that actual values. Okay, if it goes, we call those are the consistent estimates. That means if we have more and more data points, then we should have a better and better estimates. That's what it says. Okay, so the question is, are they consistent? Well, we do not have a general answer, but what we can say it here, it depends on the dependent variables, or sorry, it depends on the independent variable xi's. I'll come back to this one, what we'll see about that. Okay. Yes. So since we are talking about the robust estimates, as I said, that it is well known that the least square estimators are highly sensitive to the outliers. Okay, so they are not robust. Okay, and the reason is that you can see that, I mean, because you are trying to minimize the hello.
Ladies and gentlemen, please keep your bags under the seat in front of you and avoid using the overhead to minimize contact with surfaces. Those
Hello.
Yes, sir, you can continue. I think there was somebody's mic was
okay. Okay. So now, when you're talking about the least square estimators, you can see that we are trying to minimize that yi minus beta naught minus beta 1 xi square of that. Now, as we can see that if one of the yi's are very large or very small, then the square is going to affect very much. So that means that particular observation is going to affect the estimates quite significantly because of the square term. And that's the reason that people have realized, actually, even from the legend itself, legend Gauss, everybody has realized that. So this should have been a much better way to look at the things instead of the square, that absolute value of yi minus beta naught minus beta 1 xi, the absolute value of that. But the problem with that is that it is very difficult to compute, okay? Because these computations of the C, in case of the linear regressions, in case of the least square estimators, you can obtain this beta 0 and beta 1 very easily, because you simply differentiate and you put in equal to 0 and then you get the solution. But the problem here is that you cannot differentiate this function because this function is not differentiable. Okay, because if you look at the function mod x, which is not a differentiable function at the point 0. Okay, and that is the whole problem about trying to find out the estimates. Okay, computationally, it's a very difficult problem. Okay, it is not very easy to solve this problem. Computationally, the function is not differentiable, and there is no explicit solution of beta 0 and beta 1. That is a major problem. That's the reason that people did not do it for a long time. And not only that, I mean, this is another component. I just put it because I thought that it is important. That in case of the least square estimator, establishing the properties of the least square estimators are very simple. Okay, it's not very difficult. We know that one. But similar thing is not true in case of the least absolute deviation estimator, which is definitely not true in case of the least absolute deviation estimator, because it needs quite a bit of intricate technique because of the differentiability problem. I'm not going to address the second one, but I'm just going to address the first one, how to handle these things computationally. This is a very, very nice approach which was suggested actually in 1970s, and that's the reason that it becomes so popular after that. Before than that, we did not have much choice. I hope many of you know what is the linear programming problem. Okay, it's a very, very nice problem which was actually invented during the World War II. Okay, the linear programming problem, which can be put it like this. I mean, I have to maximize a function, linear functions, which is of the form of A transpose X. Okay, here X is the variables. Okay, A's are constants, A's are known. I'm trying to minimize a function A transpose X, where X's are variables, and X's satisfy these equations, linear equations, which is called AX is equal to B. So that matrix A is known, the vector B is known, and so this thing is known, that X is going to satisfy this constraint, AX is equal to B. Under this constraint, I want to minimize or maximize, because the maximization is not a problem at all, because if you know how to solve the minimization problem, you know how to solve the maximization, because you just put a negative sign. That's it, nothing more than that. So either you need to minimize or maximize A transpose X, subject to the condition that capital AX is equal to B. Here, A is a vector of dimension P, X is a vector of dimension P, capital A is a matrix of M by P, and B is also a vector of dimension P. Here, Xi's are greater than or equal to 0. Okay, so this is a standard linear programming problem, and we have a solutions, explicit solutions. We know how to solve the linear programming, and what is called the simplex algorithm, based on which we can solve the linear programming problem. Okay, interestingly is that if you're looking at this least absolute deviation problem, LAD problem, this least absolute deviation problem can be converted to a linear programming problem. It's an amazing result. It's an amazing, interesting way of do the things. So therefore, I have to solve a standard linear programming problem to obtain the least absolute deviation estimator. And once this result was established, somebody has said B will be M constant. Yeah, B is an M constant. Definitely, absolutely. Yeah, B is an, yeah, whenever I'm talking about, oh, let me just see what I said. B is an, oh, yeah. B is an M, yeah. I'm sorry. Yeah. B is an M cross 1 vector. Yeah. It is B1, B2, Bm. Absolutely correct. Somebody has said that, somebody has pointed the mistake. Yes, absolutely correct. B is an B1, B2, Bm. Absolutely correct. Good. Thank you. Yes. It is not P, it is M. Okay. So what you can do, you can convert this least absolute deviation problem to a linear programming problem. And after this paper, after this result, this least absolute deviation estimator becomes a very, very popular one because people could use it. I mean, that's the whole thing, actually. People could use that because there are lots of nice techniques which are available to solve the linear programming problem because it is well known. So people could do it. Okay, so that's the way it has been done. I'll keep this one as an exercise, simple exercise. I'll please do this one, and that's what I always tell. Suppose you want to solve this particular one. That means when my beta 0 is equal to 0, beta naught is equal to 0, then if you want to solve this summation yi minus beta 1 xi, you can find this beta 1 in an explicit manner. Please try this. It's an interesting exercise. Please try this one. So in that case, you do not have to go for all those things. You should be able to solve it. Okay, so please try that. Okay, let me come to the multiple regressions, multiple linear regressions, which of course takes in this form. Yi is equal to beta 0 plus beta 1 xi1 plus beta p xip plus ei. Okay, so here I have p variables. So p independent variables or covariates or features, and yi, which is the dependent variable, and that is the relation what we have. And often it is better to write it in the matrix notation, actually, because it helps a lot, because both you can do the computational things, both you can do the theoretical things, which is in the form of y is equal to x beta plus e. You just put it in this manner. Here y is an n by 1 vector, x is an n by p plus 1 vector, beta 1, beta 2, beta 0, beta 1, beta p is a p plus 1 vector, e is equal to n by 1 vector. So I can write it in this manner. And of course, we know that it has a solution, that beta hat, which is x transpose x inverse x transpose y. Again, this particular one, you can get it in a lots of different ways. You can differentiate it with respect to beta 0, beta 1, beta p. That is one way. You can do it by the projection method. You can project it on the x beta plane, whatever it is, you can do this one. But you get this solution provided the matrix X is of rank p plus 1. Okay. So if it is not of the rank p plus 1, then of course you have to go for this generalized inverse and all these things that is there. Okay. So anyway, I'm not going into that one. That's what we have. Okay. Yes. There are certain issues which is nowadays what we are facing it nowadays. What will happen if the matrix X transpose X, what we call, if it is ill-conditioned, in the sense the sum of the eigenvalues are very, very close to 0. Okay, it is a full rank. I'm not saying that it is not a full rank, but it is a full rank, but it is very close to 0. Okay, and this can happen particularly nowadays in all these machine learning things, what we are seeing in nowadays, that P can be quite large. Okay, P can be very, very large. Okay, and in that case, your X transpose X can be, some of the eigenvalues can be very, very close to 0. What will you do? Okay, there is one technique which has been used, what is called the ridge regression. What you do, the idea is very simple. You add a matrix, which is some constant times an identity matrix, to the matrix X transpose X, so that it becomes X transpose X plus, say, sigma squared capital I. So make that matrix non-singular, you make it invertible, and then you take sigma squared going towards 0. That's the way it works. Okay, so that is called the ridge regression. And nowadays, another very, very popular method which is going on, where it's called the lasso by Tipsy-Danny. So which is also another popular method. Anyway, I'm not going into this one, but those are the very, very popular method nowadays which are being used, particularly if X transpose X is a very, very large matrix and some of the eigenvalues are very, very close to 0. Okay, so those are the cases that we can use that one. But I think these are the some of the important points. That, well, if you're looking at your beta hat, which is the least square estimator, which is an unbiased estimator, that is a good part actually. Okay, expectation of beta hat, which is equal to beta. If you're looking at the variance here basically means the dispersion matrix. That means that it's a matrix whose diagonal elements are the variances of beta 1 hat, beta 0 hat, beta 1 hat, beta p hat, and the off diagonal elements are the covariances. This dispersion matrix of beta hat, which will be in the form of sigma squared X transpose X inverse. And again, if you're talking about the consistency, that means if you know that this particular matrix 1 by n X transpose X, if this particular matrix converging to a matrix A, when I put this one greater than 0, it simply means that it's a positive definite matrix. I think all of you know that what is a positive definite matrix. So if this thing happens, that 1 by n X transpose X is converging to a matrix A, which is a positive definite matrix, then beta hat is a consistent estimate of beta. That means if you take a larger and larger sample sizes, your estimate will converge to the true value. That's what it says. Okay. Again, the conditions I had put it here, 1 by n X transpose X is converging to a matrix A. This is a sufficient condition, by the way. I should try to emphasize that this is a sufficient condition. So if it happens, I know that it will give a consistent estimate, but we really do not know. If it does not happen, what does it mean? That we do not know. Okay, so that is an important thing. Okay, now let me come to the nonlinear regression model, what we are talking about. Okay, that's what it is. I mean, and I need all these things because all these things are needed in case of the nonlinear regression model. And in the nonlinear regression model, as I said, my yi, which is of the form of f of xi beta plus ei. Okay, here f is a nonlinear function of the parameter beta, and that is important. Okay. First, I will talk about that when xi can be a vector, beta can be a vector, but I'll be talking about the yi's, which are scalar. Okay. After that, I'll come back to this one when yi's can be vector also. I'll give the example on that also. Okay, so let's look at a couple of models, which is a regression, nonlinear regression model, and which is not a nonlinear regression model. First, let's look at which is not a nonlinear regression model. Okay, let's look at this particular one, f of xi beta, which is beta 0 plus xi beta 1 plus xi squared beta 2 plus e to the power xi beta 3. Suppose if you look at this particular model, it's a nonlinear function, by the way. It's a nonlinear function in xi's, no doubt about that. Because it's a nonlinear function in xi's, because if we plot it in terms of the xi's, it's a nonlinear function. But it is not a nonlinear regression model. The reason is that it is not a nonlinear function on the parameters. Okay, here you can use exactly the same technique whatever you have done it in case of the linear regression model, you can use exactly the same technique here also to get all the estimates of beta 0, beta 1, beta 2, beta 3. So it is clearly is not a nonlinear regression model, although it's a nonlinear function, okay, in xi's, because it's a linear function in the betas. Now let's look at some of the nonlinear regression model. If you're looking at the first one, which is beta 0 plus beta 1 e to the power beta 2 xi1 plus beta 3 e to the power beta 4 xi2. So here you can see that xi is a vector, which is xi1, xi2, and I have a nonlinear function in beta 2 and beta 4. So clearly, it's a nonlinear regression model. It's a nonlinear function in the betas as well as nonlinear function in the xi's, and it's a nonlinear regression model because it's a nonlinear in the parameters. Same thing if you look at the second one, f of xi beta, which is beta 0 divided by beta 1 plus beta 2 xi. What we call that this is a ratio of the polynomial. Again, it is not linear because it's a 1 by beta 1 plus beta 2 xi. So clearly, it's a nonlinear in the it's a nonlinear regression model. Okay, fine. So you can see that in this particular case, these are the two which are nonlinear in the parameters and then nonlinear regression model. Yeah. These are the first one. Again, it's a very, very important nonlinear regression model. I'll come back to this specific one, which is called that alpha cosine omega t plus beta sine omega t, which is called the sinusoidal model, which is, you can see that it's a nonlinear regression model. Similarly, you can see that I have a two-dimensional sinusoidal model, f of st, which is alpha times cosine omega 1s plus omega 2t plus beta times sine omega 1s omega 2t. So you can see that I have, this one is again, it's a two-dimensional sinusoidal model that is also a nonlinear regression model. Fine, okay? So these are some of the examples of the nonlinear regression model. Why it is important? Because it is practically more useful than a linear regression model. That's the whole reason. That's the whole reason that it is much more useful than a linear regression model. Let's look at a couple of data points. Okay, these are some of the practical data points I have taken it. This is one of the airlines passenger data. What you can see. Okay, it is going on the. It's a data from this US actually for each month, and you can see that it's a nonlinear function. Okay, it is not a linear function. Of course, there is a linear trend, but there is a nonlinear function which is going on. This is another nice example. This is an example of the brightness of a variable star data. Again, this is an astronomical data, and you might be knowing that the brightness of a star actually indicates how far they are from the Earth. Okay, and as you can see that this is being recorded in one of those astronomical center, and this is a brightness which has been recorded, and it tells you that, well, how the star is moving away from the Earth and it is coming towards the Earth. So you can see that clearly there is a nonlinear pattern in the data itself. There is a periodicity, it comes back again and again, but that's a nonlinear one. Okay? It's clearly not a linear one. That's what it is. This is one of the data point which actually we have collected these data in our lab in the IIT Kanpur. This is the data what is called the vowel sound from a male which has been collected. And the reason actually I am putting all this data because we have analyzed this data point based on the nonlinear regression model, and that's the reason that I'm analyzing. I'm putting all this data. Okay, so this is another variable star data which is there, and this is another, again, this is also being collected from our lab only, IIT Kanpur. This is the ECG data of a normal human being. Okay. Now I think I will stop for a moment and I'll mention that why these nonlinear models are so important, because if we can model this data, okay, if we can model this data based on some nonlinear regression model, you can see that it is not only the prediction what you can do, that is of course one part, but those things can be used, those model can be used, what it is called as a compression. What do you mean by the compression? See, for example, I mean, if you look at some of these first world countries, particularly if you look at some of the Scandinavian countries, they track the medical record for all the individual of that country, starting from their birth. Okay, so just imagine you are keeping the data cannot see anything in that. Cannot see anything in chat or read if miss feedback link. Oh, I don't know. What does it mean? Anyway, so
Sir, I have a question. I
yes,
want
please,
to
please.
know that Cobb-Douglas function, econometric models,
Yes.
that is a non-linear?
What is that function? I do not know. I mean, can you just...
A raised to alpha, I think so. It's in terms of labor and capital, it's been expressed.
Okay.
K raised to alpha, L raised to beta, something like that.
Yeah, should be. I mean, as long as it is a nonlinear in the parameter. Okay. I mean, you can send it to me an email. I mean, I can have a look at it and I can tell you explicitly. Okay. I mean, you can always do this one. I mean, I can do that one, but I do not know that model. But you can send it to me. I can definitely tell that one. Okay. But again, I'm just coming back to the basic one. As long as it is a nonlinear in the parameters, it's a nonlinear regression model. Okay. As simple as that. Okay. Is that okay? Is that clear?
Yes, sir.
Yeah. So to be more specific one, you can just send me an email. I'll be able to tell you looking at that one. Okay. I do not know that model, but yes. Okay. So is that okay? Can I continue? Hello, can I continue?
Yes.
Yeah. So so the reason actually whenever I'm talking about the what we call as a compression, just think about it, that I want to keep this ECG data for a particular person, okay, each month maybe, okay. See, huge amount of space it is going to take. On the other hand, if you have only few parameters and the model function, then I don't have to do much, okay. It's a much more reduced space I need, and that's what it is being done actually, okay. The compression, I mean, that is being always done. The compression, that means I just need to keep some parameters only, not the whole data, okay. And that's the reason that it is being used quite extensively for the compression purposes, okay. So some of the data in the two-dimensional one, as I mentioned, and these are the data in the 3 dimensions. The pictures are there, okay. And this is also the data in the 3 dimensions, okay. So yeah. So now some of the important questions. First of all, is the model identifiable? And this is a very, very important question in any nonlinear regressions. Okay. So these are the 4 questions. Let me just ask this first, and then I'll come back to one by one. First of all, is the model identifiable? We'll see that example. Are the parameters estimable? How to estimate the parameters? And the properties of the estimator. So all these 4 are very, very important actually. Okay. So now what do you mean by whether the model is identifiable or not? Let's look at that. When you're talking about whether the model is identifiable or not, which simply means that suppose you're looking at 2 different functions, f1 and f2, and suppose the function f1 of t alpha and f2 of t beta, if they are not equal, at least at one point, then I will call the 2 functions are identifiable or different, okay, because If they are everywhere, they are same, but at least in one point they are different, then they are definitely identifiable. That means I know that the difference of the two functions. But the problem, what happens that whenever we are trying to do the analysis based on the nonlinear regression model, but we may not have enough data to distinguish the two nonlinear regression model. That's what sometimes it happens. So we have to be very, very careful about this one when we are talking about the whether the models are identifiable or not. Maybe the two functions are identifiable, but whether the given data can make that identifiability or not. That is an important thing. We have to keep it in mind. I think this is one of the very, very classic example. I mean, I have two different functions, f1 t alpha and f2 t beta. The first one is alpha 0 plus alpha 1 e to the power alpha 2t. And the second one is f2 t beta, which is beta 0 plus beta 1 e to the power beta 2t plus beta 3 e to the power beta 4t. Of course, if you're looking at the entire real line, you can see that there are differences, okay? But for a certain choice of alpha 0, alpha 1, alpha 2, and beta 0, beta 1, beta 2, beta 3, beta 4, in a specific range of t, okay? Because you always have the data, only the finite amount of data, okay? You do not have the data on the entire infinite range. You have data only on the finite range. It is always possible, particularly for this kind of model, what you can see that in a specific range, the two functions behave exactly the same. You cannot make them distinctions. You cannot make them indistinguishable. Okay, so those are the problems what we face in a nonlinear regression one. So the model discrimination, the two models, whether they are distinguishable or not, the two functions may be distinguishable, but based on the data, whether you can do it or not, we have to be careful. You need to know about those things. Another one is that whether I can estimate all the parameters or not. Okay. And if you remember, we have a similar problem in the linear regression also. In the linear regression also, we cannot, not all the times we can estimate all the parameters. Similar problem what we have it here also in the nonlinear regression also, we may not be able to estimate all the time all the parameters. I think if we just go back to this example, I'll just go back to my old example here. Here, exactly this example, suppose you're looking at it, a nonlinear regression model, the second one, that f of xi beta is equal to beta 0 divided by beta 1 plus beta 2 xi. Suppose I am trying to fit this nonlinear regression model. The question is whether your beta 0, beta 1, beta 2, they are estimable or not. Actually, they are not. You cannot estimate all the quantities beta 0, beta 1, beta 2. The reason is very simple, because you can see that I can always divide it by beta 0 in this model. Okay, so you can see that here I cannot estimate all the three parameters. I can estimate only two parameters. Okay, so the estimability is an important thing in a nonlinear regression model. Okay, so whenever we are trying to analyze a nonlinear regression model, two things first you should ask: whether the models is identifiable and whether all the parameters are estimable. Okay, again, I do not have a general solution. As I said, you have to do it case by case basis. That is a very, very important thing in case of the nonlinear regression. Anyway, I'll continue. Okay, so this one you have done. Yes. So of course, this is the most usual way. You are looking at the least square estimators, which you are trying to minimize the yi minus f of xi beta square of that. You try to minimize with respect to beta. Okay, so that's the way you are trying to do this one. Well, I mean, you assume that everything is nice. What do you mean by everything is nice? That means that, well, the functions are nice differentiable functions. That means all the fj's are differentiable functions. You can differentiate. So that means my q is also differentiable. So you just differentiate with respect to the beta j's and you equate them to 0. So that's what you do. You have sorry, there are p plus 1 actually, because I have a beta 0, beta 1, beta p. So That's what you do. You have a p plus 1 equations. You try to solve that. Okay. So that is the Newton-Raphson method. In general, you can use that. Okay. In general. Okay. Most of the time. Let me put it that way. Okay. So if you expand by this Taylor series, if you expand this q prime, which is the derivative vector basically, if you expand this this one, which is that q prime beta hat, you are assuming that suppose there is a solution beta hat. So that is my q prime beta hat minus q prime beta. I put this one as an approximation one. You can see that the reason is that because I have an error term which I have ignored. Okay, so this is the first term, the first order approximation. So q prime beta hat minus q prime beta, which is approximately equal to q double prime beta plus beta hat minus beta. Somebody asked some question. Okay, so okay, so let me just continue. Yeah, so that's what we have. So this q prime beta hat minus q prime beta, which is q double prime beta times beta hat minus beta. Okay, so this is again, I mean, this is the Taylor series approximation close to the true solution beta hat. So that's what we have. Of course, my q prime beta hat is equal to 0 because that's a solution. Q prime beta hat is equal to 0. So I got it from that negative q prime beta naught, which is approximately equal to this quantity. Okay. So now again, you make certain assumptions. You make the assumptions that your q double prime beta naught is invertible. And so that's what you got, that your beta hat, which is approximately equal to beta naught minus q double prime beta naught inverse times q prime beta. Okay, so that's what it is. And that is precisely what the Newton-Raphson method takes you. That is the form of the Newton-Raphson method. So that means that at any point of time, you start with an initial guess beta 0. Okay, then you obtain the next one beta 1 by these equations. Beta 1 is equal to beta 0 minus q double prime beta 0 inverse times q prime beta 0. Similarly, you can get your beta 2 as beta 1 minus q double prime beta 1 inverse q prime beta 1. And that's it. You keep on doing this one, and then you stop the iterations when it converges to express. There are lots of ways you can think about the convergence. Either beta k and the beta k plus 1 are very close to each other, and things like that. Okay, some kind of convergence criteria. Well, it is much easier said than done. There are lots of issues in the simple steps. Okay, first of all, how do I choose the initial value? Okay, that is the one common thing. Whenever I teach this course, the students ask, and my simple answer is, I wish I had the answer in a global framework. Okay, we do not have the answer in the general framework. Okay, we do have answers in the certain cases. We have certain procedure that we can follow to get some initial guesses, but definitely not in general. Okay, that is one of the standard problem in any optimization problem actually. Okay, and any optimization problem, that's a standard problem. Okay, often we ignore, but it should not be ignored. Okay, so the initial value, how to choose the initial value. The second is, we got a solution. Okay, we got a solution by this Newton-Raphson method. Whether it's a global solution or a local minimum, it's a global minimum or a local minimum, because we are looking for a global minimum, because I'm trying to find out that particular value which minimizes that function, and that we are doing it by solving those nonlinear equations. Okay, but it is just a sufficient things, but that may not give you the global optimum. Okay, is it a global solution or a local one? Again, we do not have any explicit answer all the time, because most of the times we cannot answer that. Okay, again, we have to look at it case by case basis. Another big problem what we find that the matrix Q double prime, which is a Hessian matrix, can be close to a singular matrix. Okay, so we have to do certain things whenever we deal with those things. Okay, so we have to be very, very careful, and we have to adopt certain things that whenever it's a singular matrix. And of course, another problem what we often face that, well, you have all those nice properties of the Newton-Raphson algorithm, but it may not even converge. Yes, it cannot converge. It oscillates. It can happen. It can happen. Okay, so these are the challenges what we face in a nonlinear regression problem. Okay, so which is much different than a linear regression problem, because linear regression problem we do not have these issues. Okay, because we know that there is no initial value. We know that the solution is a global one. Of course, this problem is there, Q double prime, because that is equivalent to the matrix X transpose X. But at least we know this one, how to tackle that one. And the convergence does not take place because that is an explicit solution. Okay, so that is the main difference between a linear regression and a nonlinear regression. Okay, so now, yeah, so let me just move. Yeah, somebody has said something. Okay, so now, yeah, as I said, we do not have a general solutions. It depends on the model, and I think that's what it keeps me going, because it makes it interesting. Because if you're trying to deal with a new model every day, you are trying to deal with new method every day, it is challenging as well as it is difficult. Okay, so that's the way our research is also going. Okay, some of the things I would always suggest, try to use some of the graphical tools. Okay, if it is possible, try to plot the function and see this one, that whether it is working or not. Sometimes use not only the Newton-Raphson method, there are lots of other optimization method. Try to use that. But again, I would always recommend, don't use anything blindly, because nowadays a very, very standard thing that people just use it, closing their eyes, using the R or some of the software. You get a solution, but you do not know whether that's the correct solution or not. That's what always I tell my students. I mean, all my PhD students, all my MSc students, I always tell, getting a solution is not the point. Getting the correct solution is the main issue. Okay, so you might get a solution by using a R software, but that may not be the correct solution. Okay, so you have to analyze, you have to think. Okay, you have to always go back and you have to analyze the solution, whether you are getting it, whether it makes sense or not. Okay, I think that's what I would suggest. Third point is that, which is a very, very useful one. Try to reduce the dimension of the problem. Suppose you have a 5-dimensional optimization problem. Can you reduce it to 2 dimensions, 3 dimensions, 1 dimension? It is possible sometimes, depending on the model. Okay. And the last one, which is sometimes what, I'll come back to this one, I'll just explain this, what is called the step factor modification to the Newton-Raphson algorithm. That means, we'll see what does it mean. Sometimes it helps actually. Okay. So this is the step factor modification. The step factor modification is, without this lambda, if lambda is equal to 1, what is called the usual Newton-Raphson step. Okay. So if you remember, if you see this one, actually, what it tells you, at any point of time, you have that value beta k, and it gives you the directions in which you should move so that you can go towards the minimum value. That's what the direction tells you. But when you put this step factor, which basically tells you that, well, you are moving the correct direction, that part is okay, but do not move the entire length. You move maybe half of the length or maybe 1/4 of the length. Okay, so that is called the step factor modification. And sometimes it really gives you a wonderful results. I mean, I'll come back to this one and I'll show it to you. Okay, it gives you wonderful results. Okay, 2 important questions, of course, whether the least square estimators are consistent or not. What are the asymptotic distribution of the least square estimators? Again, the first parts are very important, whether the consistency or not. So that basically tells you that how good are those estimates, because often it happens in case of the least square estimators. In the case of the nonlinear regression model, you may not get consistent estimate. Okay, and let me just see. Oh, what is the range of the lambda? Very good question. Very good question. Somebody has asked me what is the range of the lambda. Well, yeah, the range of the lambda, actually, to be frankly speaking, it is 0 to infinity. Okay, but for all practical purposes, it is 0 to 1. Okay, 0 to 1. The way it works, I think it's a very good question what you have asked. When you say this on the step factor modification, the way it works, you start with lambda is equal to 1. Okay, and you see that if you move to the next iterate, whether you are minimizing the residual sums of square or not. If you actually minimize, then sometimes you want to increase lambda. Okay, that is called the greedy algorithm. That means you are becoming greedy because you know that you are moving to the correct directions, so you want to move more. Okay, so you can make that lambda more than 1. That is called the greedy algorithm. On the other hand, suppose you say that putting lambda is equal to 1, you say that your residual sums of square is not decreases, it increases, then you reduce lambda. Then you make lambda to half. Okay, instead of 1, you go to half. Okay, and that's the way what we call as a step factor modifications. Okay, fine. Is that okay? Is that fine? That's what it gives you. That way you can be greedy. That means you can move more than 1, so that it can move faster to the true solutions, or it can be smaller, so that you do not overshoot. Okay, that's what it is. Anyway, so yeah, 2 important questions: whether the least square estimators are consistent or not. This is not a very easy thing to answer in case of the nonlinear regressions. We have certain sufficient conditions, but again, we will see this one that those may not be enough. Okay, and the asymptotic distribution of the least square estimators, and we need these asymptotic distributions because it can gives you the confidence interval of the nonlinear parameters, estimate of the nonlinear parameters. That's the reason. Yeah, similar to the linear regression model, as I had mentioned here, that 1 by n x transpose x converging to a positive definite matrix, we have a similar things in the nonlinear regression also. I'm not going into the detail because there is no point in that, so I'm not going into the detail of that. Okay, yeah, I think this is important one because with this, that is the last one. A special case I'll be talking about. So this is one of the model which is being used enormously in the signal processing literature, which is a nonlinear regression model and which can be expressed like this, yt, which is in this form. Okay, fine. So you can see that there are p components, p sinusoidal components, there are AKs and BKs, and there are omega k's. So I have to estimate all those quantities based on the data yt. Okay, here my xt is the error actually, which is the et. Okay. Well, that is my aim, that I'm trying to estimate AKs, BKs, and the omega k's from the data yt. Okay, so I'll first give you some of the very, very popular method which are there in the engineering literature, and then I'll come back to the least square estimator. Okay, so this is one of the most popular method. This is called the periodogram estimator. The periodogram estimator, you are looking at this function I theta, okay, which is 1 by n summation yt cosine theta t square plus 1 by n summation yt sine theta t square. You are looking at this quantity. You wonder why you are looking at that quantity to estimate your A, B, and omega. Okay, it will be clear from the example. I am looking at this particular model. Suppose your yt, which is in this form, you can see that it is cosine 0.2 pi t plus sine 0.2 pi t. So your omega 1 is 0.02 pi. Your omega 2 is 0.05 pi. Your A1 is 3, A1, B1, A2, B2, all are 3. Okay, I plot the function I theta. Okay, I plot the function I theta, which is this function. So this is theta is on the x-axis, I theta is on the y-axis. I plot the function I theta, And you can see that the function has two peaks. And you know where are those two peaks? These two peaks are close to this point 0 to pi and point 0.5 pi. Okay, so those are the two peaks. So basically, the two peaks of that function gives you the estimate of omega 1 and omega 2. Okay, fine. And you can see that if you know this omega 1 and omega 2, you can always get the estimate of A1, B1, A2, B2 by simple linear regression technique. Okay, so that's the way these engineers were using it very often. They call the periodogram estimator. They simply plot this function and then try to get the estimates. But there is a problem. Problem is, I look at the similar model, okay, but I just change the parameters slightly. So this 3.0, I took the same thing, the first component. The second component, instead of 3, I've just taken it 0.25. Everything else remains same, nothing else. I have taken the error to be normal with mean 0 and variance 2. Okay, so the error has increased and I have changed those A1, A2 I am keeping it same, A2, B2 I have changed. Now I am plotting the function I theta. And you see that the second peak has gone. I have just left with one peak. Okay, so you can see that. So even if that method works for certain nonlinear regression model, it may not work for all the models. Okay, so that is the, I would say, beauty of the nonlinear regression, that well, a uniform method may not work all the time. But the standard method will be the least square estimator method. So you try to minimize this quantity with respect to all the nonlinear parameters. You can solve this problem. It is a highly nonlinear problem. The least square estimators has several local minima. So there is this huge numerical issues. Okay. Second one is that most of the standard Newton Raphson method may not even converge. Okay, so that is also another problem what we face. Okay. Another issue is that even if they converge, it may not converge to the global minimum. That's what I had mentioned before. It may converge to the local minimum. Okay. And you can see that if P is very large, it's a very, very high dimensional problem. Okay. So that's what it is. Okay. So another theoretical issue, this particular model does not satisfy the standard conditions, what we had mentioned, that it will give you a consistent estimates. So these are all sorts of problems this particular model has. Okay, so that makes it the model very, very interesting. On the other hand, this model is a very, very useful model in analyzing many periodic data, because all those data, all those examples I had given you at the beginning, all can be modeled using this one. Okay. So I am skipping this one. So yeah, so this is the one what we have suggested. We have used a sequential procedure. We have used a step by step. We do one at a time. Suppose my P is equal to say 10. I do not want to solve all the 10 at one go. I do one at a time solving. That's what we have done. Okay, and which basically reduces the number of dimensions. Okay, so we first estimate the first component. We take out the effect. We take out the effect of that. Then we move to the second component and so on. Okay, that's the way we move. And as we can see, that it reduces the computational burden significantly. Okay, for example, P is equal to 25. Instead of solving a 25-dimensional optimization problem, we need to solve only 25 one-dimensional problem, which is a much easier to do it. It does not have any problem about the initial guesses, because you can simply plot it and you can know where the solution should be. Okay, and the most important thing is that it produces the same accuracy as the least square estimators. Okay, fine. I think I'll stop it here, because the time is more or less up, and I think this is a good place to stop, because one of the particular nonlinear regression model I had discussed, and that's what it is. Okay, so now I'll keep it. If anybody has any questions or any comments, I think it will be highly appreciated. Yes. Yes. Any question? Hello? Hello?
Yes, sir.
Participants,
Participants, any question, please? Sir, can you suggest us some good book on non-linear regression? Which
Yes, there is a very good book which is by I can tell you can write it down or I can send it an email also. It is by Sieber and Wild. That's a very good book actually. It is Sieber and Wild. And let me just put it in your chat box actually. I think it is a Sieber.
Sir, even if
And
you have written something because you have designed the course, if you can give us that reference book too. Something written by you.
I do have. I'll share it with you. I'll try to share it with you. Okay. Yeah.
If the
Yeah.
PDF file
Actually, I
is
have.
possible, if PDF file is
Sure. I have several papers on these things. Okay, on the nonlinear regression. Okay. I'll share it with you. Okay. Fine. Yeah.
yeah.
Okay. Nonlinear regression. Yeah. There's a very good book actually. Yeah. The Sieber and Wild, and I usually follow that. And yes. Yeah. Anything else?
thank you so much,
Yeah.
sir,
I mean.
for this. Okay, sir,
Yes.
continue.
I did not.
Sir, someone has asked, please explain the some data analysis implications.
Data
Jaiveer,
analysis implication. What do you mean by that? I mean, can you just
Jaiveer,
data analysis?
can you be more specific? What do you mean by this?
Yeah, yeah. What do you mean by the data analysis implications? I mean, as I said, I mean that. See, you have this data. Okay, you have this data. For example, say you have the data. For example, if you're looking at this, the ECG data for a normal human being. Okay, so if you have this ECG data, YT, so you have the time and you have the YT. You want to fit a nonlinear regression model to this one. That means you want to estimate actually your A1, B1, A2, B2, AP, BP, as well as you want to estimate omega 1, omega 2, omega P. And most of the times you have to estimate P also. Okay. So, I mean, all these estimates. And how does it useful? Because it becomes useful because you try to predict in the future. And as I said, so that means you can predict in the future, and so that's the way prediction will be. Okay, so what you only need for the prediction, you only need those estimates of the parameters. You do not need the whole data. You just need the estimates of the parameters. That's what the implication basically means. That I mean, you are able to explain the behavior of the data based on that model. That's what it is. Okay. Is that okay? Is that fine?
Yes, sir. One more question has
Yes.
come. Sir, can you explain ordinary least squares and principles of least squares? What is the difference?
What is that? What is the order?
And the PLS something.
No,
OLS
no,
ordinary least squares and principles of least squares, and what is the difference?
no. See, the thing is that these are the different methods of estimations. Okay, so you have a linear regression model. Okay, so as I said that suppose you are looking at the data x1, xi, yi. Okay, so ordinary least square basically gives you are trying to minimize the vertical distances. Okay, so you basically looking at yi minus beta 0 minus beta 1 xi. Sometimes it can be you can look at the orthogonal distances. Okay, so that's what they're looking at it here. That means that you make a projections from the yi onto the plane beta 0 plus beta 1 xi. Or as I said, that instead of looking at the square distances, you might have to look at the absolute distances. Okay, which is the least absolute deviation. Okay, so those are the different method of estimations. Okay, your model remains the same, but you have a different methods of estimations. Okay, but of course the most simple one, because it is easy to obtain, is the ordinary least square estimator. That's what it is. Okay, so your model does not change, your assumption do not change. Only thing is change is the different method of estimations, and it all depends that what kind of distances, say, because at the end of the day you are trying to minimize the errors. Okay, so now how do you define the error? Because the errors are not unique. You can define the error as a vertical distance. You can error the distance as a horizontal, as a distance, an orthogonal distance. You can define the error as an absolute distance and things like that. Okay, fine. And even say there are methods what is called the Huber distances, which is different than all these things. Okay, so all these things are there. So these are the different methods what you can use to estimate the parameters. Is that okay? Is that fine?
Yes, sir. Next question,
Yes.
which Dr. Sagdev have asked. Even I do have same question. When to use non-parametric regression?
Oh, I mean, non-parametric regression, you should use it. I mean, if you have no idea about the function, okay. And so one of the problem, let me put it this way: if you have a very small amount of data, the non-parametric regression may not work. But if you have a huge amount of data, the non-parametric regression works. But again, I would suggest if the parametric regression works, then definitely we should try to use it. The reason is that because the parametric regression always can give you a better result, but of course it has its limitations, as you know, because that you have to have a good parametric form. But if you have no idea about the functional form at all, then only you should go for a non-parametric one. But at the same time, you have to have an enormous amount of data on that. Okay, fine. Is that okay?
Yes, sir. Thank you.
Sure.
Sir, one more question.
Yes,
What
please,
is
please.
the use of Moore-Penrose theorem in the estimation of regression analysis?
Mm-hmm.
What is the
Yes.
use of Moore-Penrose theorem in the
Yes.
estimation of regression analysis?
Yes. 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 Now, what is your question?
Sir, this is only the question person has
So
asked.
the question is, what is the use of Moore-Penrose?
Oh, I see. I see. What is the? Oh, I see. I see. I see. What is the use? Oh, use is very simple. That, as I said, that well. So when the matrix X transpose X is a singular matrix, okay. Suppose you are looking at a simple linear regression. Your matrix X transpose X is a singular matrix. Then your X transpose X inverse does not make any sense. Okay, and that's the time what we called as a generalized inverse. Okay, what we called as a generalized inverse, which is another form of this Moore-Penrose inverse. Okay, so that's the reason that if the matrix X transpose X is not a full rank matrix, then you should go for the Moore-Penrose inverse. That's what it is. Okay, is that okay?
Yes, sir. I think
Yeah.
so it's answered. Anyone
Sure.
else has any question? Please put in the chat box. Sir, no questions. No more
Okay, very good.
questions. Yeah, Aradhna madam, over to
Yes,
you.
ma'am.
Over.
Okay, ma'am. Thank you, ma'am. Thank you so much, sir, for this wonderful session on regression analysis. And I'm grateful for the time and effort you took to share your thoughts and knowledge with us. And one thing I must say that your research, years of research and depth of understanding and your ability to present the subject in such an interesting way produced one of the most memorable talk of this conclave. So thank you so much, sir, once again for joining us and bestowing us with your presence. Thank you, sir.
Thank you. Thank you. It's my pleasure. Okay. Hope we'll meet in person sometime. Okay. All
Okay,
right.
okay, sure,
Sir,
sir. Yes,
just
sir.
a minute. We'll have a
Yes.
clip with you,
Huh.
with everyone. All the participants, please switch on your camera so we can have a one click with sir. I request everyone to switch on. Pratiksha?
Yes,
Yeah.
I'll click the picture.
Yeah, please.
A request to each
Yeah,
participant,
everyone,
kindly
please
switch
come
on
on
your
the
cameras
screen.
so we can have a picture for together.
Yeah, everyone, please. I don't want to see even a single one not visible.
So are you all ready?
Sonia, madam, you can remove your mask from your face. I hope you are at home. At home, I think so. Yeah, I request everyone.
Yes. Thank you so much, all of you.
Okay, thank you.
Thank you very much, sir.
Thank you.
Thanks,
Thank you very
Vivian,
much.
sir.
It's my pleasure.
Hopefully,
Okay,
we'll see you soon at Mumbai
sure,
in our
sure.
college.
Definitely, definitely. Thank you very much.
Thank you,
Thank you
sir.
very
Thank you,
much.
sir.
Okay. Bye.
Bye, sir.
Bye-bye, sir. Thank you so much.
Now we'll be having a session on paper presentation. So all of you can be with us. You can, your presence will, I'm sure that will motivate the UG students, UG participants who are going to give about their talk. Just check that. Aisha, is the sir has joined? Dr. Dharmendra Yadav sir has joined. Okay, I'm
Can't
giving
see,
him a call.
Yes, Mule, sir, you have raised your hand. Bolo.
वो बोलने के लिए रेज किया था.
बोलो बोलो.
आशा मैम.
Yes, sir. Speak.
वो दोनों बच्चों का आ गया क्या? अनीशा ने भेजा है,
अनीशा
देखो
वाला
आप.
तो आया है, मैंने ऐड इन भी किया है, बट आपका एक ग्रुप का आया है तो वो मैंने ऐड इन करके भेजा है. हाँ, सुबह मैंने देखा तो मैंने ऐड इन किया है. एक का आया है. नाउ अनदर वन कैन प्रेजेंट इट एंड लेटर ऑन सबमिट इट. नो प्रॉब्लम. Yes, here I would like to make an announcement that whatever we got, we are making them present, but others, those who have not yet given us, submitted their presentation, please do the submission. Link is there in your group. Please quickly do the submission. So it will help the teacher in charge to effectively present it, help you out for the smooth conduct of the presentation.
Asha ma'am?
Yeah.
Ma'am, sir hasn't joined us.
Sir hasn't joined or
No.
he has joined?
I can't see.
No, ma'am, we can't see, sir.
Okay, okay, then I'm calling him. Just give me a second.
Yes, I think. Is this?
हाँ सर, ज्वाइन कीजिए, आपके लिए इंतजार चल रहा है. अच्छा, आप किस नाम से, किस नाम से? रिचा सिंह, प्लीज. ओके ओके, थैंक यू. हाँ हाँ हाँ, श्योर श्योर, आपने ज्वाइन किया है. ओके. हाँ सर, मैं उन्हें Monish,
Please make
take Richa
Yes,
Singh
yes,
as co-host because sir has joined with his wife's account.
या मैं रिनेम कर रहा हूँ मैडम.
Yeah.
Kismet ma'am, can you please share the slide?
Yeah, sir has joined.
So very good afternoon everyone. Can you hear? Yeah,
Yeah,
can you hear?
yeah,
Yes.
very good afternoon, sir. I hope you have received my mail also. In
Yes,
that,
yes,
I
ma'am.
have given
Yes, yes. Yeah, we have. I think
marking scheme. Yeah,
in this
marking scheme of.
in this technical session, I have actually. I think
So
there
you
are
may have the 9. Here,
9.
core group is, yes, 9 to 10 are there. If
Mm-hmm.
anything, if it doesn't happen, then it may postpone to the next session. But I'm
Yeah,
sure
actually,
that up
ma'am,
to 10
in
we
this,
can cover.
yeah, in this list,
Yeah.
we have 8.
Yeah,
8
I will hand over this session to Aisha Sheikh. Please, Aisha,
Yes, ma'am.
over to you.
Okay. So I'm pleased to welcome Dr. Dharmendra Yadav today as the chairperson for this session. So Dr. Dharmendra Yadav is presently, I'll introduce him with by taking you all through his journey of achievements. So Dr. Dharmendra Kumar Yadav is presently working as an assistant professor in the Department of Statistics and Demography at the National Institute of Health and Family Welfare, New Delhi. His field of specialization is in sampling theory, computational statistics, machine learning, and health informatics. Dr. Yadav has also worked as Senior Research Fellow at Sample Survey Division, Indian Agricultural Statistic Research Institute, New Delhi. He has teaching and research experience at University of Lucknow and University of Delhi. Sir has more than 25 research publications in various journals of national and international review. He has also been an editor and reviewer of many reputed journals. Dr. Yadav has been the member of organizing committee of many conferences and faculty development programs. He has also research collaborations with many foreign universities. Dr. Yadav is member of many professional bodies, including the Indian Society of Agricultural Statistics, Indian Society of Medical Statistics, uh, ISI Kolkata, Biostatistic Consortium, and International Biometric Society. He has also participated in many conferences organized by the Food and Agricultural Organization of the UN, and he's closely related to many US-based academic non-profit organizations. These are just some of his achievements. A very warm welcome to you, sir. We are pleased to, we are honored to have you here with us today.
Thank you, Asa, for your generous introduction. So, first of all, I am thankful to the organizer, especially Dr. Sajindal ma'am, for inviting me to join this event as a chairperson. So, thank you so much, ma'am, and thanks to your team also for organizing this wonderful event on the occasion of National Statistics Day. So, can we start, ma'am?
Yes, sir. Yes, sir. Sure.
Yeah. So I
Aisha,
think we have total 8 participants. So the list which I have
8
provided.
teams are there, sir. I think so. 9 teams are there. One more.
Okay, so 9 people are there.
9 teams are there.
Yeah, 9 teams. So I will not go. I will just say the first name. Otherwise, it will take much time. So the first one is Anus Sheikh, Malika Manu, and Khayati Desai. So now I would like to invite our first team to kindly present their presentation. And the participants, total we have to wind up this too. So we have at least 5, 6 or 7 minutes, 7 minutes for your presentation and 3 minutes for your discussion. So only 10 minutes are maximum. Okay. So please restrict your presentation only to your topic, your objective, research methodology, and conclusions. Okay. So don't very much go in the review of literature and all these things. Introduction part. Only the objective, topic, objective, and results. Research methodology and results. These 4 things are needed. Okay. So please take care. All the best.
Monish, you have to give permission to them for unmuting.
Yeah, please allow them to unmute?
As well as, yes, yeah, she is presented.
Yes. Now you can try. Are you able to unmute yourself?
Yes, ma'am. Are we audible?
Yes.
Yeah.
So good morning, one and all. Agriculture is the main source of income for nearly half of the Indian population. Most agriculture depends on monsoon rainfall. Hence, results are uncertain. In years of drought, crops are often completely wiped out. It is therefore of great interest to identify crop varieties that can give at least some yield, even when faced with drought. That is why the study of drought tolerance is very important. It is of course possible to try different varieties under various conditions of water shortage and compare results.
Yes, Anush. Indeed, it is very important to study drought tolerance. And today, myself, Malika Manu,
And I Anush Sheikh.
And myself, Khyati Desai, here to talk about the comparative study of sorghum bicolor varieties, or also known as jowar. About the data, we took physiological responses of 11 varieties of jowar at different PEG polyethylene glycol levels to create a drought-like situation in these plants. 4 traits were focused mainly: relative water content, CO2 fixation, intracellular CO2, and conductance. This is the data we have collected. We have 3 observations of every variety.
here we are going to compare responses of 11 varieties for each trait. Therefore, we took the mean of 3 observations.
Relative water content. First, let me tell you what is relative water content. In a plant, relative water content is an estimate of plant water status in terms of cellular hydration, which means that this trait tells us amount of water present in the plant cell. We plotted the data, and if you look at the graph, there's a clear trend. As PEG levels increases, the relative water content decreases. As we see, the variety PB15883, the pink line, has high water content percentage even at high PEG levels. So this variety will hold the water more in drought conditions. This is a box plot of the given trait.
Well, let me move on to the next trait, conductance. What is conductance in a plant? It is a measure of the degree of stomatal opening, and it can be used as an indicator of plant water status. If you see the plotted graph, all the varieties seem to do better at 0.05 and 0.10 PEG level, and then they gradually decrease. Here, again, the variety PB15883 has significantly higher conductance compared to others, which is at 0.2 and 0.225 PEG level. Also followed by the other varieties TX7078 and IS18551, which means even under water loss, conductance of water and food in this plant variety is comparatively high. This is the box plot of the given trait.
Let us look at the trait intracellular CO2. The word itself says a lot. The concentration of carbon dioxide in the intracellular spaces of the leaf during photosynthesis is called intracellular CO2. When we see this line graph, all varieties seem to have similar intracellular CO2 at 0.15 level of PEG. The varieties N13, PB15883, TX7078 have highest intracellular CO2 at 0.25 PEG level than other varieties, which means that these varieties will have a similar intracellular CO2 concentration and drought condition as well. This is the box plot of that red intracellular CO2.
Let's come to CO2 fixation. Let me start with an example. When you take a pen and fix a paper on a bulletin board so that it doesn't fall, similarly, this process of fixing an inorganic carbon molecule to carbohydrates in a plant is called as CO2 fixation. Now, clearly, when you look at the graph, you notice that again, the variety PB15883 has a very high CO2 fixation at 0.2 PEG level, and PB15883 and IS18551 have the highest CO2 fixation level at 0.25 PEG level, which means it will fixate CO2 better under drought conditions as well. This is the following box plot for the trait CO2 fixation.
We also created a drought tolerance index to judge the performance of these varieties on these traits. We scale the data so that different units of trait fall into the range of 1 and 0, and then took average of these responses at each level. We then fitted all these values in an equation as follows. We then received this data. As you can see in the bar graph, the variety PB1583 shows to be the best among all 11 varieties according to the equation, so that the higher PG levels have more weight. Therefore, in conclusion, we can say that PB1583 is the best variety to have CO2 fixation, conductance, intercellular CO2, and relative water content at 0.2 pg level, which is similar to severe drought conditions, and also best through our equation.
TX7078 and IS9830 are the next best varieties.
Therefore, we can say that these three varieties are best suited for drought conditions according to the data we found. Thank you.
Thank you.
Thank you.
Thank you, presenters, for your timely completion of this presentation. So now the session is open for any query. So if anyone is interested to ask any query regarding this presentation, you are most welcome. So I think there is no query from audience. So we will just invite our second team for presentation.
Thank you, sir.
Thank you, sir.
Thank you, and all the best. Now I would like to invite second team, Akanksha Jha, Pooja, Shashank Jha, to present their work. Are they available? Second team is available?
Hello.
Yeah. Yes, ma'am.
Yes, sir. Yeah, I'm asking same. Aisha, what about second team? Do they have given their presentation?
Yes, ma'am.
Yeah, please share. And is the even Monish give them the access?
Ma'am, but they are they present?
They are not present here?
No, ma'am.
So we can go to the next presenters. We'll take it in the end.
Aisha, you can post in the group. Meanwhile, yeah. Next team, sir, just announce their name.
Yeah, they are Bhavya, Dharmashi, Jaydeep.
Yes,
And
they are
Soham.
here. They are here.
Yeah, please continue.
Please give them access. Monish, have you given them the access? Bhavya, Jaideep, and Soham?
Yes,
Yes,
ma'am.
ma'am.
Everyone has access.
Everyone can hear us? Am I audible?
Yes, Jaideep.
Yeah, I think I was not audible earlier. So, shall we start?
Yes, please.
All right. So, respected Chairperson Dr. Dharmendra Yadav, sir, all the teachers and students present here, I first of all thank you for joining this session. Today, our group is going to present a project of time series analysis of Bitcoin historical price data. The project has been realized under mentorship of HOD Statistics Dr. Asha Jindal ma'am. Our group is of 3 students from TIBS Statistics batch of 2021. Myself, Jaideep Ashtamkar, along with my project partners Soham Halbandge and Bhavya Dharamse, will present this presentation. First, I will outline the presentation and give brief introduction about the flow of the presentation and terminologies. After that, Soham Halbange will get you through the data processes and statistical tests that we have used in this project. After that, Bhavya Dharamse will present time series model, which we have used in the Python to fit a forecasting model to our data set, followed by conclusions. Our aim of the project was to identify a relatively precise predictive model that forecasts Bitcoin prices. The project also gives brief insights into ML concepts and glimpse into how analytics can be implemented into practical datasets. For this project, we have selected Arima model among others, and we have used Auto Arima in Python for the same. The data in our study is open source dataset titled Bitcoin Historical Data from December 2011 to March 2021, which is available on Kaggle. We have used Python 3.9, Jupyter Lab, and some Python libraries in the whole project. Here we need to understand three key concepts, which are blockchain, cryptocurrency, and Bitcoin. Blockchain is a decentralized public network that allows individuals and organizations to store and securely transfer information and currency instantly. A blockchain information together in groups, also known as blocks. Blocks have certain storage capacities and when filled are connected with previously filled blocks, forming a chain of data blocks, hence the term blockchain. All new information that follows that freshly added to block is compiled into a new form block that will then also be added in the chain once filled. Blockchain facilitates the process of recording transactions and tracking assets in a business network, reducing risk and cutting costs for all involved stakeholders. Blockchain provides immediate, shared, completely transparent information stored on an immutable ledger that can be accessed only by permissioned network members. A blockchain network can track orders, payments, accounts, production, and much more. Blockchain has shared ledger, hence transactions are recorded only once, eliminating the duplication of efforts, thus typically of traditional business networks. And because share a single view of truth, there is a consistency in the records. All the network participants have access to the distributed ledger of the blockchain and its immutable record of transaction. Cryptocurrency is a digital payment system that doesn't rely on banks to verify transactions. It's a peer-to-peer system that enables anyone anywhere to send and receive payments instead of being physical money that is carried around you exchanged in the real world. Cryptocurrency payments exist purely as digital entries to an online database that describes specific transactions. When you transfer cryptocurrency funds, the transactions are recorded on a blockchain. Now I will explain some key concepts about Bitcoin. Bitcoin was one of the earliest cryptocurrency that came into existence. Hence the reason behind its preferential affection among people. Bitcoin emerged out of the 2008 global economic crisis when big banks were caught misusing borrowers' money, manipulating the system, and charging exorbitant fees. To address such issues, Bitcoin creators wanted to put the owners of Bitcoins in charge of the transaction and eliminate the middleman, cut high interest rates and transaction fees, and make transaction transparent. Bitcoin, as a dominant cryptocurrency, gained momentum in financial institutions around the world as a major sovereign and private organizations started acknowledging its impact. It remains to be seen how it affects mass consumer utility in the near future, but to gauge the rise of Bitcoin, its history offers crucial insights. Now, I would request my project partner Soham Halbange to proceed further into the presentation, deep diving into analytical aspects of the project.
Thank you, Jaydeep Ashtamkar. It was a wonderful introduction. So, without wasting any further time, let's move on to the data analysis. And first, we must understand what is data analysis. So, data analysis is a process of inspecting, cleaning, transforming, and modeling the data with the goal of discovering useful information and giving a conclusions and supporting other decision makings. Okay, now we must look what are the steps involved in the data analysis. First is understanding the data set. Second is the data processing. Third is the handling of the missing values. Fourth is the data exploration or the EDA or the data visualization, we call it. Fifth is the time series. Sixth is the KPSS test. Seven is the ADF test, and eight is the results. Now, first, let's talking about the data. So data, as Jaideep Ashnamkar said, it is a secondary data which we have taken from the Kaggle, and the data format is in the form of CSV, and that data format has it includes the historical Bitcoin market data at 1 minute intervals from the year 2000, December 2011 to March 2021. And it has the updates of OHLC, that is the open, high, low, and close volume in the Bitcoin transactions. And this data set has around nearly 49 like observations, and it has mainly 8 variables, namely, first is the timestamp, second is the open, third is the high, fourth is the low, fifth is the close, which are the volume of the Bitcoin currency, seventh is the volume of the currency, and eight is the weighted price. Now, second step is the data pre-processing. We must understand that what is data pre-processing. It plays an important step in the data mining process. And if there are any missing values which we have, how are we able to solve with that problem, which we will see. So, and I will also tell some libraries which we have used with the help of Python. So basically we were doing a timestamp variable is an integer data type. So it has a data type rather than dates. So what we did, we used the method from timestamp from the Python, and it computed the data corresponding to a given timestamp, and it returns the argument. So it has basically converted the arguments into the dates. Now, this data had missing observations about 25.6% of the total data set. Now, how we handle the missing values is one of the important things. So this time series data has a lot of variations against time. So imputations using backfill and the forward fill isn't the best possible option to address these missing values. So we found a more appropriate alternative, which could be a linear interpolation. So linear interpolation is an imputation technique which assumes that there is a which assumes that there might be a linear relationship between the data points, and it utilizes non-missing values from adjacent data points to compute a value for the missing data point. Now let's move on to the data exploration, what the data tells us about. So first is the summarizing the data with the density plots to see where the mass of the data is located. The second, if we look at is the lag plots, which is very important to observe the autocorrelation in the data set. And it is very crucial when we try to correct the trend and the stationarity, which we will see what does it mean. And we have to use some smoothing functions as well. The lag plot helps us to understand the data better. So we can see that, as you can see, there is a positive correlation for a minute, hour, and daily lag plots. So we observe that there is no correlation for month lag plots. And it makes sense that to resample our data at most at the daily level, thereby preserving the autocorrelation as well. As I already said, we also use another process from Python that is the resample function. What resample function does is that we did basically time resampling, that is to aggregate data into a defined time period. And we use the another function that data.resample to use to resample the stock data. And the 24 hours stands for the daily frequency, and it denotes the offset values, offsets value by which we wanted to resample the data. Now we must understand that what do you mean by time series? So a time series is a sequence of data points that occurs in a successive order from time to time. And this can be contrasted with cross-sectional data, which captures point in time. Now there are some key takeaways, like what does time series actually do? So a time series is a data that said tracks a sample over time. It can be useful to see how a given asset, security, or economical variable changes over time depending upon whatever domain you are working in, maybe the finance, medical, or the economic, which we are doing for Bitcoin. Now, let's move on to the statistical test and decomposition of the time series, which we did. So first we decompose the time series into the data, into the trend, seasonal, and the remainder components. And the series has been decomposed as an additive or the multiplicative combination of the base level. And also there is no constant mean variance and covariance. So hence we conclude that the series is non-stationary. Now, we also plotted autocorrelation plot, which is, we can see that ACF plot to visualize the autocorrelation in the data that changes over time. The above graph shows that the effect rarely deteriorates over time. So past values affect the present ones. The more lags we are including, we can say the better our model will fit the data set. Yes, there is the coefficients might predict the data set too well, causing an overfitting. So in our model, we always try to include those lag as well. Okay, now we must understand this. What do we mean by stationarity and detraining? So stationarity, it means the statistical properties of a time series, that is the mean variance and covariance that do not change over time, which I have already told. Now let's move on to the two statistical tests which we have used, which is the ADF augmented diffusion test and the KPSS. These are the basic tests. As I think I am running low on time, I would just brief it that it is a type of unit truth test that tests the stationarity of a given series. So both KPSS and ADF test does the same for us. I won't talk much about it, but I will show you the results what we got from the KPSS test. So of course we with the help of Python when we fitted the model. Before fitting the model, we have to run that whether to check whether the data is stationary or not. So KPSS showed that the series is not stationary. And while doing the ADF test, it showed that the test we did, the series is stationary. Now here comes a major problem. The one test shows the series is stationary, and other it shows that it is not. So the conclusion it is that KPSS concludes that the series is not stationary, and ADF says that series is stationary. So this precisely indicates that the series is not stationary, and hence for tackling this issue, we will use the differencing to make the series stationary. Now I would give my friend Bhavya Dharamsej a chance to explain the following concepts.
Yeah, please conclude your presentation with your results. What the
Yes,
conclusions
sir.
you have, because we have a lack of time. We have other presentations also.
Yes,
So
sir.
don't go in much detail.
Okay, sir.
You just
So,
the methodology and results.
okay, sir. So, as Soham said, that our data has different results. So, we would be separating our data into a training and a test model, where we will be training our data on the basis of training model, which is from 2011 to 2019, and our validation model will be beyond 2019. So on that, we would try ARIMA modeling. ARIMA modeling stands for Autoregressive Integrated Moving Average. With this model helps the series data to give a better understanding and helps to predict future trends. So basic notation in ARIMA is PDQ, where P stands for number of flagged observation, D stands for number of time rows observation and different, and Q stands for size of moving average. Here we have used Auto Remax, where we automatic got 21 possible models on our data, out of which the best model was selected. So we use AIC, that is Archaic Information Criterion. It is an estimator which predicts the error on the data on respective of each model. The lesser the error on the model helps to fit it better. So among the 21 available models, we have a model that is 1, 0, 2, 0, 0, and 0, 0, which we conclude as the best model for our future predictions. And this is the graph where we can see the weighted price and the forecast ARIMA. And also on the right bottom corner, there is the best model which will help us to predict the future values. So since the aim of the project was to find the best predictive model that fits our data, and we conclude that a model produces satisfactory fit and help us to understand our time series data and focus the future values. Hence the auto ARIMA model, this 10200 and 0 will help us to focus the Bitcoin price effectively as compared to other models. Thank you for the delay, and thank you everyone for paying attention. Extremely sorry for the delay.
Oh, no, that's no problem. And thank you so much for your wonderful presentation. It's really a very relevant presentation, and I must congratulate to all of you for this one. And
Thank you, sir.
now I invite queries and questions from the audience. If they have any, they can write in the chat box, or we can move further. So we will take the questions or queries in the last. So now I would like to invite our next team. Next team, it means there is a Nandini Jha. I think she is here. Jha is present. Her mentor is Dr. Suvarna Sharma. So can you listen me? Are you available?
Sir, you are audible?
Yes, ma'am.
Yeah.
Nandini, okay. So she is going to present. So Nandini, you have 8 minutes maximum. So please go, you can skip the introduction. You just go to the objective, methodology and conclusions. Please allow her to unmute. Is any problem in the presentation?
Hello.
Hello. Yeah, you are audible.
Hello.
Yes, yes.
Yes, ma'am. I'm so sorry.
You
Hello,
can,
Nandini.
yes, ma'am. Yes, Nandini, are you there?
Yes, sir. Yes, sir.
Okay, so
Just
please.
come near to device so you.
Yeah, so that we can hear you properly.
Hello. Am I audible?
Yes.
Thank you so much. So, good evening, good afternoon to everyone present here today. I'm Nandini Jha from SYBSC, Department of Life Sciences.
Your voice is not audible, Nandini.
The title of my, hello?
Yes, please be closer to your device so that everyone can hear you.
Nandini, any problem? Are you facing issues with the network? Yes, please. You can join back again. Meanwhile, sir, we'll give her the opportunity. Yeah, please you join. Join back again. Meanwhile, the next participant.
Yeah, next team can be present.
Yeah, so meanwhile you come and rejoin it.
So now I would like to invite our next team, and that is Mr. Siddharth Nakwa and Ms. Rhea Naulkar.
Yes, sir.
So
We
please,
share that.
yeah,
Yes,
please
sir.
share the screen and start your presentation. And you can skip the introduction. Just go to your methodology, objective, and conclusions.
Yes, sir. Yes, sir. Definitely, sir. So, am I audible and the screen visible?
Yes. Yeah. Both are fine. Please continue.
Okay. Thank you so much, sir. Myself, Mr. Siddharth Nakwa, along with Ms. Rhea Navalkar, under the guidance of Dr. Ashu Vajpayee and Dr. Tejaswi and Dr. Sagarika Damle from Department of Life Sciences, present you this piece of research project of our SEM 3, Paper 3 Life Sciences. The agenda of our project includes the aim, introduction, methodology, results, and conclusion. We aim to understand the preference of mode of shopping across various demographics such as gender and age in a given population. Now, the hypothesis is to test whether the age factor influences the preference of shopping. The second hypothesis is to test whether females prefer online shopping over offline shopping in comparison to males in a given population. The third hypothesis is to test whether males spend more time in retail shopping in comparison with females. And the fourth one is to test whether discounts and coupons influence the preference of mode of shopping. Now, just giving a small introduction about the e-commerce and retail shopping, which is our main topic. Now, e-commerce, it is the emergence of e-commerce almost dates back to 1990.
You can skip it.
Yes.
Because
yes,
I think everyone is aware of this.
Sure, sir.
You just go to methodology.
Yes, sir. Yes, sir. Sure. So talking about the methodology, sir, our survey was conducted using Google Forms, and the sample size of our survey was 210 responses. The sample and the age groups were broadly divided into three following categories, which is 18 to 30, 31 to 40, and 41 to 60. Our survey form is divided into 4 sections. The first section is the consent form from the respondent. The second section is giving us more of their personal information. Section 3 is talking about the online shopping and the factors affecting the same, while section 4 is talking about gives us an idea about the offline shopping and the various factors which are dependent on offline shopping. Over to Ms. Riya Navalkar.
Thank you, Siddharth. I would be discussing the results that we obtained. So the first graph depicts the preferences of modes of shopping using age as a criteria. We observed that the maximum population was concentrated in the 18 to 30 age bracket, and the offline shopping was most preferred. We analyzed it using chi-square and phi test, which are non-parametric tests, and we obtained these values. The second graph is a gender-wise comparison of shopping. We also perform chi-square test and phi test again and observe that females prefer offline shopping, whereas males prefer online shopping. Next slide, please. In figure 3, we observe that Amazon is the most popular website, followed by Flipkart and Chroma. Figure 4 talks about the time spent on retail shopping with respect to gender. As we can see, the maximum time overall is spent by females. So this talks about the fact that the females prefer offline shopping more. We analyze the data using chi-square again. Next slide, please. Figure 5 talks about online shopping factors, influence, and the factors that influence them. It is observed that quick shopping is one of the main reasons for this method of shopping, since online shopping is all about buying an article with one click. The return policy and the products being pocket-friendly are other factors that influence them. Figure 6, on the contrary, the factors influencing online shopping are depicted in figure 6. The touch and feel option greatly influences the preference of retail shopping. Next slide. Figure 7 talks about the effect of discounts and coupons. So you can see almost 55.55% of our respondents believe that discounts is one of the main reasons that affect their shopping preferences. Next slide. So from this, we conclude that we observe that the age criteria does influence the preference of mode of shopping. This was one of our hypotheses. We failed to retain our null hypothesis of females preferring online shopping over males, and the statistical analysis revealed that the male population was more inclined towards online mode. We failed to retain our third null hypothesis of males spending more time retail shopping than females, as the statistical analysis suggested that females spend more time shopping as they prefer offline shopping. The last one, we failed to reject a null hypothesis due to the large percentage of population believe that discounts influence their mode of shopping. Next slide. A study revealed that retail shopping is still preferred over e-commerce because of the recreational aspect, the touch and feel aspect, and the return and service policy for electronic gadgets. However, the review by Business Today predict that by 2030, nearly 1 billion users would be using e-commerce as their primary source for shopping. And this is probably because of the influence of the pandemic that can motivate the mindset of buyers and also the shift of the retail industry for moving towards e-business. A relatively new form of shopping has seemed to emerge during the pandemic. This is what I was talking about, the e-retailing, which is when a retail store ultimately goes online. In the future, we wish to evaluate this topic and understand the various trends influencing them. Over to you, Siddharth.
Thank you so much, Ria. The future prospects of our project aims to study the distribution of preference of online and offline modes of shopping in metro cities and smaller cities. We will also try to understand the effect of pandemic on the growth and future of a business. We also wish to understand the nature of e-retailing, which is a growing product in the market. So these are our references which we have referred for the paper. Our acknowledgements, we would like to thank University of Mumbai, Dr. Hemlata Bagla, a zealous principal of Kishan Chelaram College, faculties from Department of Life Sciences, KC College, for providing us an opportunity to conduct our research. We would also like to thank Department of Statistics, KC College, for giving us this wonderful platform to present our research. And we would also like to thank Mrs. Shailaja Rane from Department of Statistics, KC College, for her statistical guidance. We would also like to thank our respondents, which rated till 210 responses as our sample size for their enthusiastic participation. Thank you. So with your permission, can I answer 2 questions from the chat? Okay.
Yeah, definitely, because
yes,
this person is open
yes.
for
Yes, sir. So the first question is from Miss Sonia, what is the sample size of the study? As we have already discussed in our previously, that our sample size is 210 responses on our Google Forms, and the sampling technique which has been used is random sampling method such as chi-square and phi-square method. 5 test values.
So what is the criteria? Actually, I just want to ask, what is the criteria of your selection, sample size selection? How you calculate the sample size? How it comes
So the
to 210?
Google Forms were sent.
Yes.
So the Google Forms were sent to random people. So basically, we had one Google Form for online and offline shopping. So in the first section, if you select online shopping as your preference, you go to the questions of online shopping. And if you select offline, the same thing will happen. So a person doesn't have to answer the questions for both.
No, I'm not asking. You are not getting. Actually, I'm just asking about what is the methodology, what is any formula for calculation of sample size, where this magical number 210 comes.
So they are the number of respondents that we received.
Yeah, I know
like
that.
The number.
I know that. But is it that you have sent them a Google form to the respondents and you ultimately get 210? Or it is pre-decided that we will collect the data from the 210 respondents?
No, sir. It was sent to various people, and then we collected these many responses. There wasn't a preset number for the responses.
Okay, it was a preset, or you just conduct the study and this comes. That's why you mention here that we have taken the 210 respondents. So anyway, you have just go to the sample size calculation methods, and please, if you want to publish it, this study, yes, then please mention the sample size calculation formula.
Yes, and so this is a part of our project. We will be talking. Okay. We have also discussed about the future prospects of our project.
Yes, you can also publish this study in any journal in form of research paper. And 210 is too less to conclude. Actually, you can't say anything that it is less or high.
Yeah, sir,
because
I
there is
think
no certain
commenting about it, yes, sir.
Yeah,
And
because it is
yeah.
not always easy to say that this particular number is accurate
Thank you
or
so
this
much,
number
sir.
is this one.
Yes.
So it all depends that in this present scenario of COVID-19, so we have to just compromise with the efficiency
With
of
the
our research.
efficiency, yes. Thank you
Obviously.
so much, sir. Thank you so much, sir. Thank
Thank
you
you.
so much. Thank you. Thank you for this platform.
Thank you. And please, now I would like to invite our next team, which is, K. Divya, Sinthura, M. Bala Anjani Devi, and B. Sheila Jasmine, under the mentorship of Purveen ma'am. So they are here? So this team is available right now? If not, then we can invite the other team, next team. We would like to present the screen ourselves. Yeah, Sindhura? Yeah, you can present by yourself. But you have to, the host should allow you to share the screen.
Monish, please give them the screen sharing right.
Yeah, screen share option.
Yeah, it's given. They can share their screen.
Yeah, please share your screen. Sindhura, you can share your screen. And please be very brief. Just show your objective, methodology, and results. If you are having any problem, then you can tell the organizers.
Yes, Purna, are you able to share the screen?
If not
Yes,
able,
ma'am.
then yeah, please.
Please start your presentation. And participants, please stick to the timeline.
Yeah, of course. Because we have maximum 8 minutes for every presentation. Maximum. Any problem, then you can tell the
I
organizers.
think by the time they saw,
Yeah, because you are not.
problem, you can call the next group.
Yeah, next group.
Yes, sir.
Yeah, our next group is.
Sir, Nandini is remaining. Nandini can.
Yeah. Nandini, are you ready?
Hello, am I audible?
Yes, please, Nandini, continue.
Yes, thank you so much.
You can proceed.
Yes. A very good afternoon to one and all. The title of my research is Survey-Based Study to Determine the Status of Plastic Recycling in Mumbai. We have performed it. My group has performed it under the guidance of Dr. Suvarna Sharma at Department of Life Sciences, KC College. So plastic is very versatile and it has become an important part of our daily lives. However, the improper disposal, which is irresponsible and unsmart, has created a whole host of problems for the environment and the lives that it supports.
Nandini, you can escape it.
Yes, sir. Yes, sir.
Please go to your objective.
Yes, sir. So
your objective of the study.
With this study, we aim to assess the awareness of people regarding plastic recycling in Mumbai. For that purpose, we established a hypothesis that there is no association between awareness regarding plastic recycling in Mumbai and recycling habits of people. Our research methodology consisted of the following. We performed an extensive literature review that was conducted online to gain understanding of the research and debates relevant to our study. The survey for our research was conducted digitally. We designed a questionnaire that consisted of 23 questions and circulated it among residents of Mumbai through Google Forms. A pilot survey was conducted to test the efficiency of the questionnaire, and a final survey was carried out with all improvements. Total 150 responses were received, and collected data was analyzed using percentage, Z-test, and chi-square test for independence of variable. A research report and poster was prepared for final presentation. Results and discussion. Analysis of data collected from the respondents indicated, as seen in the figure 1, 99% of people are aware of plastic waste recycling, whereas 47% of respondents make conscious efforts to buy plastic products which can be recycled. And as it can be observed in figure 2, 73% of the respondents segregated plastic waste at domestic level, and 53% of them reported collection of segregated waste by municipal corporations. Here are the tables for Z-test and chi-square test for independence of variables. In the first table, through Z-test, we tested the hypothesis that participation in awareness programs by people does not influence plastic recycling in Mumbai. As our Z-test statistic value came out to be greater than critical value, we rejected a hypothesis and accepted the alternate hypothesis. The second hypothesis we tested through Z-test that their awareness regarding plastic recycling and segregation of plastic waste is not related. Our statistic value was greater than critical value. Therefore, we rejected the second hypothesis and accepted the alternate hypothesis. Through chi-square test for independence of variables, we tested the association between collection of segregated waste by municipal corporations and segregation of waste at domestic level. The hypothesis that there was no association between these two variables was rejected as the statistic value was greater than critical chi-square value, and the alternate hypothesis was accepted. We also checked the association between awareness of harmful effect of plastic to environment and recycling habit of people in Mumbai. As the chi-square statistic value was less than critical value, the hypothesis that there is no association between the two variables mentioned was accepted. So, evaluation of the data collected by means of a survey and interpretation of this result have revealed two very important findings that can help in determining a way to effectively recycle the plastic waste produced in Mumbai. Participation in awareness programs has positive effect on plastic recycling in Mumbai, and awareness regarding plastic recycling is positively related to segregation of plastic waste at domestic level in Mumbai. Therefore, organization of awareness programs regarding plastic recycling will prove to be helpful in increasing the recycling of plastic waste in Mumbai. Collection of segregated waste by municipal corporations is positively related with segregation of plastic waste at domestic level in Mumbai. This tells us the effectiveness of policies applied by the municipal corporations. Therefore, more efforts should be put in by them to implement segregated waste collection in areas of Mumbai where it has not been initiated. Awareness of harmful effects of plastic has no effect on recycling habits of people living in Mumbai. This can be due to the unavailability of affordable and easily accessible alternatives for plastics used in everyday living by the common people. The concerned authorities should focus on investing more time and effort in research development of effective alternatives of plastic and making sure they reach the masses easily. In conclusion, plastic plays a crucial role in modern civilization. In today's world, it enjoys the position of necessity as well as luxury. However, improper use of disposal of it serves as a serious threat to our environment. The null hypothesis of our research was rejected on testing with Z-test. Therefore, the alternate hypothesis that was accepted, which states that there is an association between awareness regarding plastic recycling and plastic recycling in Mumbai. Awareness about recycling is directly proportional to recycling. Therefore, it can be said that recycling habits of people in Mumbai is being positively impacted by awareness regarding recycling. Hence, concerned authorities should give more impetus to educating people about recycling. On coupling this with another finding of our survey that collection of segregated waste by municipal corporations positively affects segregation of plastic waste at domestic level, a roadmap for increasing plastic recycling in Mumbai can be designed. Recycling of plastic is of utmost importance as it takes 88% less energy than making plastics from raw materials and helps to reduce fossil fuel consumption. Since banning plastic completely is not possible, keeping in mind its importance, we can find sustainable ways to utilize it so it causes minimum impact on the environment. Research and development to find better alternatives of plastic that are durable, cost-effective, and easily available should be encouraged. There is scope for future prospects in our research. These are evaluating the status of recycling in other major plastic waste generating cities, designing sustainable strategies to effectively undertake waste management in plastic and plastic recycling in Mumbai, helping in the implementation of proper waste management and plastic recycling strategy, and evaluating awareness and status of zero waste in Mumbai. This is a glimpse of the scientific poster prepared by our team.
So thank you, Nandini, for your wonderful presentation.
Thank you so much, sir.
And now the session is open for any query or suggestion. If any, you can also write in the chat box. So we'll take it later. So I think there is no question. So thank you, Nandini.
Thank you, sir.
And now I invite our next presenter, who is ready.
Sindhura and group, na?
Yeah, the previous team, which was not ready at that time.
They are ready.
Yeah. So there is a question from Sonia. What is the tool of your data collection and how did you administer it? Nandini, do you would like to take this question?
Yes, sir. Yes, sir.
Yeah, please.
The tool of our data collection, we designed a questionnaire and then made a Google form for it. So we can send it to people, and then we just forwarded it to people, and then the data was collected.
Okay. So I just want to advise one thing, that in methodology, you have to mention the inclusion and exclusion criteria at the time of data collection. That from where you have to, from those participants or respondents, you will collect the data and to whom you will exclude. So that will be much better.
Okay, sir. Thank you so much, sir. We will keep that in mind, sir.
Yeah, and there is another question. Which statistical tool have you used to do the analysis?
Sir, we used percentage, and then we tested our hypothesis using Z-test and chi-square test for independence of variables.
Okay, independence of attributes. Okay, that's good. So
I have a question. Have you checked the reliability of your questionnaire?
Yes, ma'am. We had sent it to us, the statistics department, and Shelja ma'am had advised us on the questionnaire designing.
No, I'm not asking questionnaire designing. I'm asking that reliability of questionnaire,
reliability and validity. Actually, you have to check the validity of
Whenever
your.
you are carrying out any kind of survey-based study, it is there. It's a very important that you check for the reliability and validity. So whatever results you are then giving, that becomes the yes, it will hold true for any number of surveys when you are conducting it on the same kind of the issue. So they play a very, very important role.
Yes, ma'am. Thank you so much, ma'am. We will do it next time, ma'am. We have not done such a test yet, but we will include it in our study further. Thank you so much, ma'am.
So now I would like to invite our next presenter, who is available. Sindhura, Divya Sindhura.
Narsha Naidu.
Okay. So anybody who is present?
Yeah,
available?
she said na, she is there to present.
Yes, Miss Sindhura, are you there?
Yes, ma'am.
Yeah,
Are you
please.
presenting?
Sindhura, do you want me to share my screen, your PPT?
You
Yes,
are
ma'am. But our problem is we have kept a video in our presentation which plays automatically in phone. But we have checked in computer, but it's not working in computer. So we want to present it in mobile. So that's why we are asking to present our.
Yeah, we'll do it. Aisha shared there.
Yes, ma'am. Yes, ma'am.
That's all right, but start
Okay, ma'am. Thank you.
Is my screen visible?
Yes, yes, please continue.
Yes. Shall we start, ma'am?
Yes, please.
Yes, ma'am. A very warm good afternoon to one and all. We are here to present here. We currently matched our topic with the statistics day team, and the topic is applications and trend in statistics since independence. Before going to our presentation, let me introduce our teammates. Myself, Anjani, Sheila, and Sindura. We are the final year graduates from Manistella College, Vijayawada. Let me give a brief of our presentation. We just went with the small intro of statistics in the past. Secondly, we gave some of the applications of statistics. Next, statistics after independence and trend in applications. And finally, something interesting about how beautiful the data is. But you have to wait quite time to know it. Introduction. Next slide. These are the contents, as I already said. Introduction. Video. Here is a video of a background, historical background of statistics. And is that audio working, ma'am?
No, it's not working.
Just click on listen to the audio. Click on that. Just see.
Yes, who is presenting? Are you using any, headphone or anything? If you're using that, just disconnect from the headphone and present only using the device. Yes.
It's not working, I think so.
Have you?
Yes, ma'am.
The one who is presenting, are you using any headphones or?
Ma'am, I disconnected, but it's still not working.
Okay, you just play it now because.
Okay, then.
And describe in your own words.
Yes.
Here.
Because we have a lack of time.
You can show us the video and audio. I mean, you can give the voiceover for this video. That can be done.
Yeah.
Or it's only audio?
Yes, ma'am. It's audio. If you listen to the audio only, you can know that story.
Can you narrate that story?
Narrate the story now because you don't have.
Yeah, please narrate in your own words, maybe few words.
Yeah, yes, ma'am. The audio in the presentation depicts that the Euler will go to one of the tree and he tries to count the number of leaves in that. So, but he estimates it how many leaves are there. So, but he won't exactly count how many are there, but he just estimates them. The here he uses the concept of estimation and considers himself as a skillful person. So he uses the concept of estimation in the past itself. Next slide. As you have seen how beautifully statistics is used in the past, just imagine how creatively it can be used after all these technological inventions. Now let's move on to the next slide, applications of statistics. And these are some of the fields where statistics is being used efficiently, and quality testing, predicting disease, insurance, emergency preparedness, political campaigns, weather forecasts, and stock market.
Next, changes that were brought through statistics since independence. Since the independence, what are the changes that we have brought through the statistics are mainly the first one is the agriculture sector. Next slide. The agriculture sector continues to be an important sector in the Indian economy and generates livelihood for more than half the population. Followed by income expands. Since 1947, before slide. Since 1947, India has achieved tremendous progress in raising growth, income levels, and standards of living. The GDP increased from 3 billion during 1950 to 51 to 56 billion during 2011 to 12. Building India. India has also made significant headway in infrastructure and has worked over the years to establish a robust transport network. Statistics has shown that the length of the roads increased from around 0.4 million kilometers during 1950s to around 5.9 million kilometers post 2016 to 17. From here, teammate will continue.
Good afternoon. Since independence. Next slide. Statistics after independence. It is only after the independence in 1947 that the country saw an urgent need for a statistical framework suitable for economic and social development. Let's see some milestones that were established after independence. In 1949, Mahalanobis was appointed as a honorary statistical advisor to the Indian cabinet. Also, Central Statistic Unit was set up in the cabinet. In 1950, National Sample Survey (NSS) was formed. In 1951, Central Statistical Organization (CSO) was formed. Next slide. Now comes the important question: how statistics helped independent India? As we all are aware that there are some statistical organizations helping India since independence. NSSO, since 1950, NSS has been conducting nationwide sample surveys on different socio-economic aspects. MOSPI is concerned with coverage and quality aspects of statistic released. CSO, which was established in 1951, coordinates and advises functions. Now my teammate will continue.
Trend in applications. Next slide, please. Trend in symbol can be defined as general movement, that is either increase or decrease of a time series over a long period of time. The picture below depicts the upward trend of time series data. Next slide, please. Trend since independence. Statistics reveals that upward trend in agriculture, followed by industrial sector, service sector, resource consumption, and employment since independence. Next slide. Analyzing trends since independence. The below cluster bar diagram indicates that percentage contribution of various sections to GDP in the financial years 1950 to 2015. It depicts that agriculture allied sector has highest trend in 1950 to 51, which was gradually decreased till 2014 to 15. Next comes the industrial sector, which is almost neutral in all the financial years. Finally, the services sector has shown for upward trend in the considered financial year. Here is the next slide, please. Let's have a quick glance how beautiful statistics data can be. If you are in a group of 23 people, then there is a 50% chance that 2 of them share a birthday. If you are in a group of 70 people, that probability jumps to over 99%. McDonald's sells 75 burgers per second. By any chance, are you one of the buyer? The oldest person on Earth, Gianni Calment, has lived on the planet with an entirely different population of people. If you look at a web page, newspaper, book,
and find a random number, there is a 30% chance that it will start with a 1. Have time to check it up. More Mexicans are leaving the US than coming to the US. Next slide, please. And finally, we feel very glad for this opportunity. Thank you.
So thank you for your presentation and giving the brief history of evolution of statistics in India. And yeah. Asha ma'am, can you hear me?
Yes, sir. It was informative because they have spoken about nicely. They have linked the all the small.
Yeah, but I must say that all the
Yeah,
students
it
at the
was
UG level, they have done the wonderful job, because these things are done at the PG level or at the beginning of the research. But I really appreciate the efforts which are made by the students. So, ma'am, actually, I have told you now that I have another meeting. So,
Yes. Yeah. How many more presentations are pending? Can I know? Aisha, can I know?
I think.
One from UG. No, ma'am. Two, I think.
Two
There's
from
Anisha
UG
also.
and one from two from PG.
Yes,
Okay, we can keep it in the next session, which is at 2:30. No
Yes, ma'am.
problem.
Thank you, ma'am.
How many presentations do we have completed? Sir, how many presentations are being over? Because you may have recorded.
Yeah, ma'am. Because 7 are completed.
7 are completed.
Yes.
Yeah. Okay, sir. Kindly
Thank you.
give us the result on for all 7, and
Okay.
remaining, whoever want to present, you got half an hour more opportunity. Yes, prior to that, since sir will may leave the session, Aisha, please give him a, yeah, Aisha, session is over to you.
So, thank you, Dr. Dharmendra Yadav, sir, for your time and for your patience. We are honored with your presence today. Thank you so much, sir.
And
Thank you.
let's have one photograph, Pratiksha. All of you, please unmute yourself so we can have a one photograph.
Yes. I think my video has some problem. I'll click the photographs.
Hello, I request everyone to come on screen.
Yes.
Yeah, Nandini, Mulay sir, Bala, Shreya, Wasim.
Yes, everyone, please switch on your cameras. I'll just click the photographs. I don't know. I have switched on my camera, but it's not still not visible. I'll click.
Shreya, Wasim, Bansari.
Yes. Okay. So,
Thank you, ma'am.
Thank you very much, sir, once again.
Yeah, thank you, and all the best for your.
Yes, sir. And I'm looking
Thank you.
forward by end of day, you will send me
Thank you.
your
Thank you. Thank you.
report. Thank you very much, sir, once again. Yeah, now I think so we can have a half an hour break, lunch break, and then we can rejoin once again. And this is a time even for the ones who could not complete their presentation, whatsoever reasons are there. I think so they can work upon it and just attach in that so it can be presented. Link is already in the group, so they can.
We're actually going to add.
Yeah. Hello, anyone want to say anything? Hello.
Yes, I think by mistake somebody had unmuted.
Okay.
Um,
Yeah.
So let us
recording
have
recording can be stopped. Monish, recording can be stopped.